So, good morning, everyone. Yeah, as you probably hear, my voice is a bit crackled. I catched a cold a few days ago, and with the talking yesterday entire day, that did not help. So, I hope it will stay okay, that we can finish this this day. First, a few additions to what I said yesterday. At a certain point, we mentioned that those annotation members, those values can only be constants. And then there was the idea, can we make it some kind of dynamic? And at that point, I said, no, not with variables. And that's correct. But there is the possibility to define a string which will be interpreted later on as what's called an EL expression. So as you see in the example, you have some annotation and you say the value is dollar curly braces bean.property. With the EL, the expression language specification, you can ask for resolving that, that string value, and then you get the property for that CDI bean at runtime. Is that in contrast what I said? No, because that string is still a constant. Real for Java, it is a string like another, so it does not know what's in there and it does not resolve it automatically. But you, in a producer or in an interceptor, you can capture that string value and do something with it and dynamically resolve that value. So that's a small correction, an addition what I said yesterday. I think it was Anna who had the question about logging. So I looked a few things up yesterday evening, and for logging you have 3 different log formatters that you can specify in that property file. One is called uniform, the other one is ODL, Oracle, and I forgot the rest, and then JSON format. The only thing that you can configure there is that you can exclude some fields that they do not longer appear. But that's not exactly the same what the question was. So I tried with a custom formatter. But yeah, that's because that custom formatter is needed at the moment that Payara Micro starts. You need to do a few tricks with the class path, etc. And apparently I get an error that the Hazelcast no longer starts and that the startup failed. So no idea why. So if there is a need for that, I assume that the people from Payara itself can help you on their forum, their GitHub, or as a customer, you can request those kind of functionality, of course. And then there was also the question about Docker images, and I created a few examples on how you can create Docker images, and I put them on that extra directory in the repository, but I will briefly mention them when we cover Docker when we are doing the integration testing this afternoon. Are there any other questions that people have now, since they have maybe digested the content a bit more? They thought about things what I said, or is there any question that pops up for the moment? since I don't hear anyone and don't see anything in the chat, let's have a quick look at the agenda for today, for what we are going to cover. First of all, I'm going to review that hands-on exercise. And then I'll tell a bit more about microservices. As you know, yesterday we said cloud native does not need to be based on microservices, but yeah, a lot of people use that in that way. So a few things that I like to share about it. Then one of the other MicroProfile specifications besides config, which I find the most important one. The second most important one is REST client, and you will see why it's such a handy feature that you have there. And I also will cover briefly the other specifications and what you can expect from them. Give them a very, very brief overview because we do not have the time to cover them all. Normally, if I give a microprofile training, it's an entire day on microprofile alone. So that's then it's obvious that I cannot cover entire microprofile in these 2 days. And then we switch to another important topic because with applications, they all are centered around the data. I guess every application requires data in one form or another. They are the business value, most of the time the data. So let's see how you can use JPA in combination with Payara Micro. And then I'll show briefly a few things about JPA, but the main takeaway there is how you can configure the database connection with Payara Micro. It's not difficult, but you need, if you don't know it, you can search for a long time how you can do it easily. And then we also tell about MicroStream because that's an alternative way of data storing. And I'll tell you about why we think it is a better way of storing and accessing data than SQL databases, NoSQL, or whatever other solution you are using. Testing, very important, of course. As I said, CI/CD, that relies heavily on testing because if you do immediately deployment to production after all the tests are good or green, that means that your testing needs to be covering everything, needs to be able to test everything, which is not that easy, especially in a microservice environment. So I'll cover integration testing with the test containers framework, which is using Docker, and why that's a good idea, and give some an example how you can use it with Payara Micro. And then in the exercise this afternoon, we will update the example that we created in the first day, or some of you have maybe created it. And then we integrate MicroStream in that solution that we no longer just store our data in memory in a few lists, as you will see if I review a possible solution of that hands-on. Is there anyone that has created up to some point or entirely a solution for the exercise that I said yesterday about those products and users?
I only got so far as to have products, just no time.
Yeah, that's fine. Any comments, remarks that you said this was easy, this was difficult, this was unclear?
No, the products, but it was stuff that I kind of knew, so it was clear, and I stopped at security contest and filter, and the first problem was I didn't know what annotation to use for a container filter, but then I Googled its provider.
Yep.
And that's it. That's my feedback.
Yeah, okay. Yeah, that's the idea is that, well, I guess every developer, apparently I saw that there is a name for it, the 10x or the 1x developer. I also search a lot of things. So even if it looks like I know a few things, I know concepts and I know that it is possible, but actually how you do it, I'll look at my previous code or I even just Google it. So there is no problem in Googling for how you need to implement something, as long as you know that it is possible and that you more or less know how it works. So then I'll maybe go over what I have created. So let's first switch. Yes, share my screen, entire screen now. Again, if you have questions of why I did something, then please ask me. I think in the POM file, there was no change needed. That was fully available in the start code. We just used that web profile of Jakarta and a scope provided. And the first thing that we, of course, need to do is define that URL, the URL where all the REST endpoints will be accessible. And I have chosen now here to use just a slash and not a name like yesterday we had API and data, if I remember correctly now. Many projects should just use the slash. And then for the product resource, we have here 3 query parameters: the category, the product category, if it is a bike, a truck, or a car, and the minimum and maximum price. As I mentioned, here within this JAXRS resource class, it is a good thing to validate those input data. So I check if they're both filled in, then the minimum price should not be higher than the maximum price. And then I give that return status of 412, the precondition failed, with an error message. And that error message is then here a simple POJO. But since I say that I return JSON, then my return of the error will be a proper JSON payload, as I said, not the HTML error page. So that's one of the things that I mentioned yesterday and that I'm using here now. If it is okay, then those values, I find the products which potentially matches those parameters that you specify, because I did not specify the not null, so you can leave them empty or do not specify them. So then I have here first of all, if you creating a filter based on the parameters that I specify, because I want to use here the stream API. from Java. And yeah, and it's already preparation for the micro stream. You can see that that your data can actually be in memory, and that you can query them very quickly, with a lot of options, with a lot of functionality using that entire stream API. When I get those results, I just return them, and the system will take care of converting it to a JSON, that list of products to JSON. I will start it up in a moment. Just telling a word about that databases. We have just a CDI bean, application scope. We only have one with the 3 lists of categories that we have: products, users, and what I called user items. Naming is probably the hardest bit of the entire project. So that's all the product items belonging to a certain user. And when that database initializes, we just create some initialization values, and we pre-populate it, and here we created a list of products which are available by default. Question: can you tell us why resource classes are application scoped? I've put here says a singleton, but application scope indeed is the same. Actually, it's not needed, but then there is a new class created for every request user makes. But actually, for me, that's an overhead, because this class does not contain any user-specific information. This inject, yeah, that's a service class. Again, that's stateless. This product resource is also stateless. So why do you want to create a new instance for each request if actually you can reuse each instance for every request? And it is even thread safe. There is no data stored here within these resource methods that are request specific, so it's also thread safe. So instead of having the JVM creating every time a new instance and the garbage collection need to clean it up every time, just create one single instance as a singleton and reuse it over and over. When processing the query, if the parameters are typed wrong, string instead of integer, is it possible to cover this error with the JSON error message? Not the default is. Yes, that is possible, that you get a proper error, but again, for that you need to define a exception mapper or a filter. I do not remember it by heart, but with an exception mapper or a filter, you can capture the fact that the values that you have specified here, that the values that the user has specified in the query do not match the type, and that you can return a proper return value. Again, that's one of those things which are not explicitly specified in the specification, how you should return that error. So that's why every implementation has a slightly different way of doing it. And Payara just returns the XHTML error. Follow-up question about Jerome about why this, if it was singleton application scope, if you do it like this, actually, then the implementation itself can decide if it's what type it is. And I think because it cannot know your code, it does not know if it stores something in a value in a instance variable or not. That means that if you don't put anything like this, then it creates a new instance each time. So that's the reason why I should use application scoped and not singleton, but I'm so used to doing it with singleton from the old days. But application scoped is a bit better than singleton. There is some long technical description about the reasons, so not going into that for the moment. But actually, most of the time it is identical, and it is a bit better that it is application scoped because that's a real scope. You see, that's a scope, a normal scope, and singleton. Please use the CDI one, not the EGB one that works with Payara, but not with everyone. That's what's called a pseudo scope, not a normal scope. So there is slightly difference, and yeah, application scope is actually a bit better. So let's try it out already, just that you see that it works. So this is my application and Java manager. And I shouldn't forget Payara Micro, of course. It starts up, and as I said, everything is there. So this shows me then the entire list without any filtering. And then you can see that I have all the JSONs, so the entire thing is working. The users is a bit the same, of course, only where there we have secure, and for user items also, so that the system needs to know which. Why is that now in error? Whatever, it's compiled. So that the system knows for which user it is. And for that, I created that authentication, that container request filter. And then indeed, you must specify an annotation. For completeness, I mentioned yesterday that you can have here some methods that you can implement. Wait, where is it here? All the all the singletons, and that you can add, for instance, then this clause there, and then you don't need this provider. But I don't put anything here normally. I'm used to do everything with an annotation. This is more or less the same thing, or it is exactly the same thing that I showed you in the demo around the filter. Taking that base 64, so you could have copied that from that example there. You need also to create a specific security context, because you know how you're going to handle the security. In this case, it is rather stupid, if I might say. It is just relying on the fact that it is a valid base 64. There is not even a check on password, so I'm not checking some kind of database or data storage about the credentials. So there's a reason why you need to use that custom implementation. But there are, of course, as I mentioned, better solutions. So if you really want to do it in production, then you should have either look at the MicroProfile JWT authentication spec, or you need to look at the Jakarta security API. with those two specifications, one in Jakarta, one in MicroProfile, you can create any kind of authentication that you like. OpenID Connect, these tokens, database credentials, as credentials that are stored in the database, which are encrypted and secured, etc., etc. All those things are available out of the box. Yeah, there is one thing about those payments that was only in advance. That security was also only in advance. There is mentioning that you could have two payment ways, by card or by credit card immediately, or invoice. Again, that's just some placeholders. But that means that we have a CDI bean, both implementing the card and the one implementing the payment service. So how can we inject it? And that was in, my brain is slower because of my cold and all the things that I took to make it through the day. That is in the, I have to look for it. It's, I can have a look at payment service. Where are the usages? Is user item service. You see, I'm using the trick with instance. Because we have multiple one, and then we filter for the correct type with the user specified. And so each of those beans has the information of for what type it is, which is with a classic solution, and we can just filter them all and take the one that the user specified. And if no is specified, you see, or else throw a runtime exception. It's a runtime exception. Payment service is not supported. Which is a runtime exception. So I should have a exception mapper. I should have a custom exception hierarchy, as I told yesterday. So that is not in this example. So I thought it was already enough, but you see, it's not even fully 100% complete. So that's a brief overview. Just look at that solution branch, check it out. There is one thing that is also not discussed yesterday, but was also here, that you can define a query parameter as a list of strings, and then it just capture multiple things here. The example is here, so you can add multiple products at the same time. Where is it? Here you see product ID is B02 and product ID is C01. So as query parameters, you can only specify it multiple times, and that is then covered by the specification by just using here a list. As I said, check out that solution branch one of the next days, weeks, but then whenever you have time, whenever you feel that you want to play with it. And see what is possible. How I solved it. Again, this is one possible solution. There are multiple which are equally well, but yeah, there is no single best way to do it. Any other questions about things? Because now we are moving on, we leaving day one behind, and we will move on with new things. So a few words on microservices. There is still a huge debate, best practices. I even saw this morning someone who said, well, if you're using microservices, then the first microservice that your request hits needs to provide the entire answer. It should not delegate part of it to another microservice. Then, so you see, there are 101 opinions about how to write microservice the best way. I can understand why that person said it like that. I come to that in a moment. So every solution is unique. I think every environment, every company is unique. So try to do the things that sounds the most common, the most logic. Let common sense prevail over all the hype things, purity, whatever. Just make that it works in an optimal way for you, but taking into account some of the best practices that you should consider. So I'm trying to go over a few things that you can that you might consider when you're going to do microservices. First of all, as I mentioned already, we are using microservices through that REST, but we tend to move away from the original ID from REST, and we are using remote procedure calls over HTTP. Try to avoid that a bit. Just try to indeed concentrate on the data that you are sending, update an order, update a customer. Also reflect that on the naming of your endpoints, the URL. But some things cannot always made in the philosophy of REST, because, for instance, what I'm always struggling with to put in the correct way is if you have an endpoint to validate credentials, that's kind of a login URL endpoint, but you can never make it a proper endpoint following those REST principle, because it's always a remote procedure call. Validate is create the credentials and return some kind of token, etc. So that's that will always be a remote procedure call. But yeah, make sure that you try to concentrate on data, update, CRUD, create, retrieve, update, and delete, and not by saying get or perform login, send invoice, or those kind of things. Microservice should be independable, upgradable, and scalable. That's one of the key aspects of microservices, but that is very, very, very difficult to achieve. Because if you're really working with a very large team, where, and that's the idea of microservices, where, let's say, at the pizza size team, so what is it, 4 or 5 people work on one microservice, and they talk only through that open API or documentation to other teams, then if that one microservice team comes up with something new, then they say, oh, we are going to change our implementation. That's fine. But if they say, oh, we are going to change our endpoints, we are going to change our return values, we return another JSON, a completely different structure of JSON. Well, if the other teams don't follow, the microservice will no longer work. Your entire application will no longer work. So that's independable, upgradable. That's very difficult due to that backwards compatibility requirement. That means if you have a microservice, think very carefully about what your endpoints will look like, how your return values will look like. Some people go then to the extremes, and instead of returning proper JSON, they return some kind of map-like structure. That's also a bit of JSON, but not really for instance, they don't return a person, but they return just a generic map where one of the fields is, oh, this is something of type person, just because they want to have the possibility to define each property they like in the future without breaking the backwards compatibility. But again, that's unnecessary complexity that you introduce in the entire system, because your client needs to also cope with that. If you then go to strongly typed, which I surely encourage, because Java is now a strongly typed thing, so why don't you use it then also for the communication? Then probably you need multiple versions of your microservice. So if that microservice teams, that pizza team comes up with a new version, well, they can deploy it in production and say, well, the old version is still supported for the next 6 months. And we have already a new version, and please, other teams or even external customers, change your code to adapt to that new version in the next six months, or it will no longer work. But you see, that's an additional complexity, because if they find a bug in that older version, yeah, I guess that needs to be solved. And so microservices are not that easy as some people pretend that it is. I assume that there are some comments on this, because this is an opinionated statement, which is not shared by everyone. I see that one person at least agrees with me, but you do not need to agree with me, of course, but that's what I found the last 10 years of working with those microservices. Sorry. So the idea is indeed a monolith. If you need to scale a monolith, every piece of functionality within that monolith is grouped in one dependency, in one WAR file. For instance, in the early days, it was an EAR file, a big enterprise archive file. So if you need to scale it, then yeah, the only thing that you could do is start up a second instance and through load balancing, make sure that the new version is also considered, meaning that you probably need to share the user state session, so that you need a session failover, etc. But most of the time, yeah, there are that 5 blocks in that, the orange, blue, green one, etc. Most of the time you need to scale up, because one of those parts is just used a lot, and you scale the whole thing, and of course you duplicate everything. You duplicate the entire application on a new server with a large application, or potentially a large application, which is not ideal, because you only need to scale up, for instance, that orange one. If you have all those functionality in those microservices, of course, and then you can scale up there much easier. You can scale it independently. You still need load balancing, and that's why Kubernetes comes with those ingress controllers. By the way, if you have worked with it, you know that it is also a difficult topic, networking and the entire load balancing in those kind of environments. But it is then, of course, more efficient on the level of the instances that run your microservice. But with those separation in all those different microservices, then of course all the complexity comes with how do you communicate between them. Okay, it is REST, but you have like 5 microservices, as you see on, or 4 in the left diagram, but your client sees only one application. So you need to install probably something what's called an API gateway that, based on the URL, calls the correct service that needs to be providing the response for that client request. So that's an additional piece of software that you need to install, maintain, that you need to master, that you need to know how it works. And you can do a lot of things with it. You can do there already the security. That's why there is on top that identity provider placed there. It can check if the user is authenticated, that the tokens are valid, etc. That's then something that you can put outside of your service. That's correct. But then again, you put a lot of functionality in the API gateway. Some people even put kind of converters into that API gateway that convert the data which are coming from the client in a format that is suited for the microservice. That makes it a bit easier for that microservice to change the format, and then you only have to change the converter in the API gateway. But you see, then you put that additional functionality, and you need to maintain it. You have complexity also there. Services probably need to talk to each other, because the idea of microservices is that each microservice is only responsible for one domain, and what's called domain-driven design. For instance, that red service is responsible for everything around products, so it keeps a list of products and the price, for instance. The yellow one is responsible for the stock in the warehouse, to see how many items of each product is in that warehouse. The green one can be the order. If they are placing an order, then that is keeping track of the order, and the blue one at the bottom is the customer. But they are not independent. It's clearly that if a customer places an order for a product, you need to see if there is stock available. So in one sentence, I mentioned those 4 services already, so they need to talk to each other. I did not put the image here. I should have done it. Netflix released an image of their microservices and how they are interconnected. Well, that is just a black screen, because there are some dots on it and there are so many arrows that the entire image is just black, because the arrows from one service to another was in a black color. So there were so many interactions that probably, and I think they even admitted sometimes, they don't know what each microservice does, and if someone needs some functionality, then they just create a new microservice. They don't even bother of checking out. So they need to know where the microservice lives, that service discovery. A call can then pass through those 5, 10, 20 microservices. That means also latency, because every time you do a call, you have the overhead of Java objects back to JSON and etc. So that's why people started to have something like a caching in each service. So each service caches all the data of the other services. So the product service caches the stock, and that means that, okay, that red service does not need to call the yellow one to know if there is stock available or not, but that also means that you need to update, that you need to send events most of the time it's done with events in an event-driven way, that you send an event from that yellow service to the red service saying, hey, the stock is updated. So again, more complexity to make it working properly. This is then on the right, including that event source mapping. That's now here with Lambda functions with serverless. That's even a step further than those microservices, where you still have that API gateway, where then a certain Lambda function is called, which you can see it as a microservice. And here then they say, oh, all the information is available, not only my own information from my own microservice, but all the information is available in DynamoDB tables, because they want to use immediately JSON. That's one of those databases they can store JSON. There are many, of course, but DynamoDB is specifically for AWS and has great scalabilities. And they need, of course, to promote their own product, of course. That's asynchronous invocation. So the user makes a request, the Lambda function returns the result immediately. But then there is an asynchronous invocation with an event. That can be any kind of event saying, oh yeah, an order was made, so that means that the some of the stock is now reserved for that person. So we send out an event, is asynchronous, and then those events are captured by those same microservices or other Lambda functions there, saying, oh, if I receive the notification that there is a new order, then I need to update my stock, and I update my database, and I send out a new event, maybe to make sure that new products are purchased to replenish my stock, etc., etc. So it becomes complex. The only thing that you need to be aware that if you are going the microservice route, and there are several cases where it is a valid way of doing it, be aware that you're going to a path that you need a lot of new components, API gateways, event-driven systems like, for instance, Kafka, and those kind of things. Again, an opinionated thing. Is there anyone that wants to comment on what I said? And as we have seen in definition, cloud native does not mean microservice. So don't be ashamed that you say, oh, I'm doing cloud native, and you just deploy one single application in your environment, because simply it is easier, and probably most cases, like 99% of the cases, it will do just fine for your situation. You need integrations, with other systems, etc. That's, of course, no application is an island, but consider carefully before you start with something. And then I mentioned already AWS Lambdas, and then people say, yeah, but Java is too heavy for the cloud. For instance, for that serverless, Java cannot compete on that serverless with what is it, Python, JavaScript, and Node.js, etc. There are several people that investigated that, and also Java is evolving, and they all come to the conclusion that Java does just fine for even on those serverless AWS Lambda functions, because with those serverless environments, the amount of CPU is related to the amount of memory that's selected. remember in that infrastructure as a service in that cloud model, you can define, oh, I want to have that kind of CPU power, and most of the time you can select, of course, within a certain range, you can select a few memory sizes which goes along with that CPU. With AWS Lambda, for instance, and I assume also other environments, I did not check all them in detail. You just select some kind of size of your environment. So CPU is always related to amount of memory. So if you say I want one unit of CPU, so an entire unit of CPU, then you probably have already like 512 megabytes or 1 gigabyte of memory, which comes automatically together with that. If you say, yeah, but I only need 46 megabyte of memory because I have a very small Lambda, the code is not that large, then yeah, then you get only 1/10 of a CPU, for instance, and so that CPU that you got assigned of it is limited to only supplying 1/10 of the actual physical time to your application. So it goes rather slow. So there is saying if you want to have some reasonable CPU speed, because most of the time your functionality within the Lambda or the microservice needs to perform some kind of real world problem, not hello world. So it needs to have some CPU, it needs to have some power to calculate that, for instance. Then you get automatically quite an amount of memory with that. So if you say I need 1 unit of CPU, you have more than enough memory to start up Java in a fast way. Adam Bean, it's a very known person, and probably a few of you already know him also. He made a comparison between JavaScript and Node.js invocation of an AWS Lambda, an identical piece of code between Node.js and Java. And he found comparable performance. It was like 32 milliseconds versus 34 or 35. Okay, Java was like 3 milliseconds slower, but is that the point that it was 3 milliseconds slower? I guess not. And as I said, Java is also evolving. One of the features that not many people know is class data sharing. If you start up your program, your process, then Java loads the entire all the classes that it needs at that time. It does some checks on it. It does some security checks on it, validity checks, etc., which takes some time. But with class data sharing, you can prepare all that class information upfront. So you prepare what's called a read-only memory mapped file. So it is a file, read-only, strictly read-only. Even the root user cannot modify it, can only delete it. And in that file, the entire class information is already prepared in the format of the JVM itself. You know that class data is operating system independent. It can run on Windows, on Mac, on Linux, whatever. But once it is in memory, loaded by the JVM, it follows the implementation of that operating system. So that read-only memory map file stores already the entire class information as it is useful for the JVM on that operating system. And it stays on the disk, but it is mapped in the memory space. So it can be accessed. So it's not loaded, it is accessed immediately from that disk location. So that means that if you are preparing that file, that class data sharing file, you can achieve up to 35% of performance increase at startup time. I did that with Payara Micro. You can find the blog and even a few talks about it, where I demonstrate that if you just start up Payara Micro, as we did here with Java minus jar Payara Micro, if you do that with class data sharing enabled, that it goes 35% faster. You also have that native compilation. Native compilation is good for startup. It's faster startup. It's also good for lower memory consumption. So that's two things. But remember that for the moment, the natively compiled Java code is slower than the JIT compiled Java code. So when both program starts up and they are receiving requests from the user, after, let's say, a few seconds or a few minutes, depending on how many requests there are, the Java JIT compiler can do so many optimizations that it is faster than the native compiled Java code, because of those optimizations that it can do based on the information that it sees how your application is used. Native compiled code is what's called closed source. So it cannot take into account anything of how it is used. It is compiled upfront, so it needs to take into account all possibilities, all branches, all trees of source code execution, which means that it is slower. It can be significantly slower. It can be up to 5 to 10% slower and natively compiled code. Start faster, but it goes then afterwards it goes slower. They have now found workarounds for that. You know that you run it once, that native compiled code with some kind of collector which collects all the information. That information that I think it's called a compiler profile or something. That compiler profile can then be used at compilation time to optimize the compiled code for runtime. But again, it's more work and it's not that easy to do, of course. Things will change in 5 years. That can be changed again completely. Something other, what I did not, well, I played a bit with it, but not extensively, is something what Azul is doing. They call it the JVM on crack. CRAC, and it's not a drag, but it is coordinated restore, and I forgot the last C one, which actually just dumps the entire JVM status, what is in memory to file. So you start up the entire JVM, and then you create a restore point, which means that afterwards, if you start up the process again, you start your JVM at the same state as it was when you stopped it. That means the JIT compilation information is there, the optimization is also there, etc. So that means that you have extremely fast startup times. It's even up to 70 to 80% reduction of startup time of a normal JVM. And again, the performance is still 100% afterwards because it has all that performance optimizations that it has collected in earlier runs. So if someone says Java is not suited for cloud, it's not suited for serverless, then that's not true. It is certainly as good as any other like JavaScript or Python. Questions or comments about this, of how you can maybe give a few scenarios how you can speed up if performance startup is really an issue. And again, startup time of 3 seconds or 4 seconds, I don't think that's relevant for most applications. I'm not saying that it is not relevant at all, but most applications. But if it is relevant, then you can do a few tricks like class data sharing, like native compilation, like something new, which that Java on Crack, which is actually proposed as a standard for OpenJDK. So Azul is willing to donate that technology to the OpenJDK. So you probably it will take 1 year or so to incorporate it in all JVMs, but you probably will see it in the coming year in more distributions. Questions, someone about this topic, about microservices? Because I think I covered microservices now and what you have to watch out. Some architectural things about that you need to cache data in microservices, that you probably need to event-driven communication, asynchronous to update data across your environment, etc. Okay, good. Well, I like feedback, I like comments, but if there are no comments, that's also fine. MicroProfile REST client. The point is, how can we make a call to a remote service over HTTP easier? Let's switch back to the XRS demo we had yesterday. Because there it's a bit slow because I'm sharing screens. I discussed here briefly that that client resource, how you can here, based on that client builder, you can say what you need to say is first, oh, I want to call a certain HTTP and a certain URL with HTTP. I'm putting the header there. I probably want to put some parameters. I think it's called parameter. It's not parameter. How is it? It is before that. See, I have here a query parameter with what I need to add, etc. So it works fine. It's a good thing. It's probably better than just using the HTTP client of Java SE. So you have more strict control of what you're doing. It's easier, it's clearer. But still, it is not that great, if you ask me, because in that response, you can have here that read entity. You can just say a string clause, but what if it is a JSON? Then you need to convert that information, that string, to a JSON yourself. So that's why we have MicroProfile REST clients. It's not the open reason because you did not open it yet. Okay, yes. It's two applications, so I need an A and a B. So I need to open from the REST client, I need to open A, and I need to open B. It's becoming more and more complex, of course. It's really slow. Don't know what's going on. Okay, so I have everything opened. Hopefully now it goes a bit better. We are talking about MicroProfile, so I need just to provide the dependencies as provided. What if we could say that we have some kind of service, which is an interface? I'll show it immediately what it is. So it is an interface. I inject that interface, and I say as a kind of qualifier that's a REST client. So this qualifier will then make sure that a producer is there that creates a dynamic implementation of that interface, which is capable of calling a remote service. And how it needs to call it, it's defined in that interface. But the nice thing is that you can do just something like this. Call me the do something method on that remote service. What is that do something that's then defined in that interface? Well, that is a GET request on a certain path. And that parameter that I specify as in the method, that's part of the path parameter as you have seen here. That makes it extremely easy to say, call me a remote service. Because it looks like the JVM method, but actually, if you do this, it is calling the remote HTTP endpoint. Here on this side, we need to say on this interface that it will be used for REST client. And of course, there is one missing piece. We have only here a path, but we don't have the host. But of course, that host will be probably different in test, acceptance, and production. So that's the reason why it is a configuration property. Where we say, well, this interface, this is the fully qualified class name of that service interface. The URL for MicroProfile REST, yeah, it's a bit strange as naming convention, but okay, it is what it is that URL. So our automatically generated proxy for that interface will use this HTTP service / parameter, whatever I specify here. And what was it? It was, oh, I'd take it from another call. What do you think? Is that neat, or is it Spring has also something, I forgot the name. Anna, I know you do Spring, so someone else will do Spring. It is Slut or something, is it Spring Slut or?
I've used a REST template in Spring, but it wasn't quite that easy as this. And there's a new thing that I don't know, yeah, but it's cool. Yeah.
So let's see it in action. I just do a Maven clean package because I'm lazy, and then I'll get that URL. That's the only reason why I do. Need is another screen because I need to start a Payara Micro device. So yeah, I've put it here. So I started up that service B, and I explicitly say now that it is another port because I cannot start two processes on the same port, of course. So service B will be on port 8180. Then this also allows me to show you another feature that of Payara Micro, that automatic clustering that I mentioned, but I did not show it yet. And I started here. I start here service A. You see, is this service, this instance saw that there was another service starting, and Payara uses Hazelcast for that. These two instances are joined at this moment. You see that there is this is false, this is true. So this is the unique ID of this instance. This is the ID of this instance, and it will also show that there are that they are linked. And Payara Micro, so they are sharing that Hazelcast that in-memory data grid. It's called an in-memory data grid. So whatever you put as data in that grid on this first instance, service B, is automatically visible in that grid in service A and vice versa. You can make use of that. So for instance, you can make use of the Jakarta specification and the JCache specification. That if you put something in the cache, then it is automatically also available in the cache of this instance. Payara Micro also use it to communicate information about it. For instance, you can use it to do session failover. So if you have two instances running, then the session information can be shared through this way. So it works here locally, as you see on my machine. It works in a network. It works automatically in Docker and Kubernetes because it detects the environment where you are in. And for instance, if you have running the same services twice in Kubernetes, for instance, through a service, for those that know Kubernetes, if you define two replicas of your deployment within a service, then of course they share it and they can use it. That's one of the nice things that I like about Payara Micro and Payara Server in general is the ease of clustering, of sharing information between different instances. But that's not REST client, but it is the opportunity for me to show a bit about Payara Micro and the functionality, because that's also the topic of this course. So we have now our application service B is running here. And service A is running on that other endpoint. So that means if I do a curl here and I tell more in detail how it is working, what the mechanics are, then I get a result back. Not spectacular, but if you see what's happening behind the screens, then it is nice. So I call service A, I call this client controller test microstream. And so that was the URL that I did, client test microstream. So that corresponds here with client test microstream. So my parameter is here, microstream. Then it goes to this interface saying do something with it. And it says, well, call me a remote endpoint, which is defined here. So it is service B data client service. Service B client service, and we get the parameter here. And it says processed value parameter. And we return that value. So actually, this processed parameter value microstream is produced by service B and not by service A that we are calling. Okay, the nice thing is how you can call it. It looks like an in-memory call, but it is remotely. Why I find this so cool, so nice, it can be very helpful if you are splitting up chopping up your monolith. Because at first, you probably have maybe an interface or a class where that functionality, which is now in service B, is located in the same deployment, in the same WAR file. If you just say inject a service, that can be a service which is defined here somewhere, a normal class then in that case, and it provides you the functionality. The only thing that you need to do, well, you need to copy that functionality initially to that other service here. You put a few JAX-RS annotations on top of it. You put here also JAX-RS annotations on it, and you can make it a remote call without changing your code. You only need to do a copy paste of a few things and putting some annotations. It's probably a bit optimistic what I'm now saying, but it is more or less like that. So if you know what you're doing, you can take functionality, what's two parts of the functionality which included in one service. You can split it up in, let's say, in a matter of 15 minutes or 30 minutes due to that REST client. That REST client, you can also use it programmatically and not with here an annotation. We will use that in the integration testing because it is very nice thing to do it also for integration testing. You can do a few things then, of course, with that REST client. Maybe I did not mention it, but you maybe have seen it. This is printed out by an interceptor because that's probably the hardest thing. Defining the correct URL for that remote service. At least I find it always challenging. So what I mostly do then is I register here a provider. So I register some additional functionality. And in this case, it is a client request filter. Remember, we up until now, for that security, we did a container request filter. Now it is a client request filter. So whenever the client sends out something, we get the possibility to intervene. And what do we do here? Well, we just say, print out, it's a quick and dirty way, what URI it's URL in general, what URL it's created for calling that remote endpoint. Because if you start doing this, you always end up with 404, the URL is not found. And then you ask, what URL is he trying to call and is wrong? This easy functionality, can you find out from, oh, he generated that kind of URL, why? And then you can see that you maybe have a path value here not correct, or you have that this configuration not correct, etc. But basically, you can define any kind of filter interceptor what needs to be used by just using that register provider here. What you can do is, for instance, the user is authenticated in service A, so we know somewhere the JOT token, so that JOT token, we can propagate that to service B here. The same with this kind of client request filter. We can here change the information that it's going to send by adding, for instance, a header, having that token. Another thing which is very nice, which doing here is you can automatically convert a synchronous call, because this was a synchronous call that I used. So this return does not happen before the actual service B responded with the value, of course. But you can also convert this to something in a asynchronous call. Let's look at service B. Service B, I have here another endpoint, which is a heavy calculation. It's just sleeping for 2 seconds, but you know what the idea is. That remote call can take a few seconds, few milliseconds, a few seconds, whatever, but you don't want to wait for that response, because you can do in the meantime something else for that same request for the user. So for instance, you get a request from the user and you need to call 3 or 4 different microservices, but you don't call them in series. You don't call the first one, and then if you get the result back, you get the second one, because probably you can call them in parallel, send out the call to 1, 2, 3, and 4, and then collect all the information, assemble it, and return it to the user. What do I need to do for it? Instead of returning, just say that my remote call returns strings, my interface returns strings, I say that it returns completion stage. Completion stage is one of those things from Java SE itself, for concurrency, for doing things in parallel and multi-threaded. What is this client then doing? So I get a call. Service A gets a call, and he launches the call to that remote service, service B, but that's a completion state. So that means that this statement returns immediately. Well, after it has launched the call, of course, but it returns immediately. It does not wait for the response. So I can continue here in this caller. Okay, I can do also sleep because I need to have some realistic timings. But then at some point, I'm ready for retrieving the result. That can be before the result is ready, then it just waits, or it can be when the result is already received, then of course I get immediately a result. From that completion stage that I get, I convert it to a completable future, and I do a get, which means I get a string back from that remote service. And then I can say I received the result, for instance. It's of course difficult to do all those asynchronous, to visualize all those asynchronous ways of working, but I try to do it with some logging statements. As this is service B, so let's start with service A. So it first calls the remote service at everything happens at second 38 and then 276 milliseconds. It immediately returns. So you see continuing caller. So that means that service A continues the processing and it does not wait the 2 seconds because it is 200 milliseconds later. And then 1 second later, it says, okay, I'm ready for retrieving the result. And then he gets more or less 2 seconds after he made a call, he received the result. And here he received the request from service A. See more even after that he continued in the caller, you see, so that's purely asynchronous. And then he says 2 seconds later, I'm returning the result. I hope that I explained it good enough, because those asynchronous is not easy to visualize and what's happening. But the nice thing, remember, if you want to call it asynchronous, don't put the return value here, but put completion stage. And then, yeah, you can continue asynchronously in parallel what the remote service is doing. The question is, can you get also the body in JSON? Yes. That's one thing that I forgot to mention in the first part. I'm not returning here anything, so I'm not saying the type, but if I would say I'm returning of type JSON, then he converts it to JSON, which does not make sense for string. But if I return a person, then he returns the JSON string. And if I put in here in that service consumes JSON like we did before, then he converts that JSON automatically to the person, for instance. So indeed, you don't need to bother anymore to do the conversions yourself. You only are working with Java types, no longer with strings or JSONs or whatever. Any other question about this REST in the client request filter? I don't know by heart if I don't think that at this moment, no, I'm pretty sure at this moment, if you are working here with a request filter, at this moment, you are still working with Java. You're not working with JSON. That happens later. That happens in the writers and the readers, and they come after the filters. Was that, Kral, is that now answering your question? Yeah, I will look into that indeed. I'm not 100% sure, but first of all, yes, JSON is automatically, and if I'm remembering correctly, this filter still operates on the Java objects, not on the data which will be sent, and so not a string, not the JSON. Talking about asynchronous, we have now seen how we can work asynchronous on the client, which is in my opinion, the most important thing. But we can also work asynchronous on the server. Maybe I will not run it, but I deliberately did not mention this yesterday because I knew we were talking about asynchronous today. You can also say that your response here will be done asynchronously. And that's you have a AjaxRS method that performs some functionality, and that, for instance, I have here a completion state. So I create a completable future, I execute, and that's the managed executor. That's the asynchronous thing that is available within Payara Micro, although it is part of the full profile because it is so useful in background jobs, etc. Payara Micro supports it also within Payara Micro. I can ask for an executor service, so that's something that can run a thread for me in the background. I submit it, and I can return the result for that completable future. So if you look what's happening, then this statement is executed, this statement is executed, but only the submit. Then this return is happening, and then afterwards, by providing the value to complete, the value that needs to be sent back in the response is submitted, is handed over to the internal logic of the implementation of Payara Micro of JAXRS, and will send it back to the client. Question: what does this add? What benefit does this way of working has? Maybe it does not have a benefit, or maybe it has only a benefit in certain scenarios, certain situations. So, question: does anyone of you know when this is useful and when this is not useful? Someone is unmuting.
Yeah, I have no idea, but I was wondering, what does it look like in the browser when you starts this?
You don't see any. You don't see any.
You don't see anything.
You don't see any difference.
You don't see any difference.
That's a good question. You ask yourself, what does it bring for the client? Well, that's part I already answered. Nothing at all.
Nothing
for
at
the
all.
Client, there is no difference at all. There might be a slight difference, but okay, let's first go for why is this then useful? Why is this useful on the server? Maybe it's not useful, and that entire asynchronous is.
Well, if you do something else after, so you can parallelize. Here
okay.
you don't do anything else,
Yeah.
but if you go on and do another something which costs
indeed.
time, then yeah, then I don't know. That's it.
But then okay, it is possible. Yeah, correct. A good remark, which I did not think about when I created this example. When you do some other stuff here, then indeed it is useful to do something like this, to submit a task, a thread separately, but then actually you don't need this return of completion stage, because you can just create here the completable future
and wait on it.
And then you can here wait until that result is there, and then you can return the string. Good point. So yes, it is a good way of doing asynchronous in your creation of the result, but that does not say why maybe this asynchronous at the JAX-RS level is useful or not.
Does the container do anything with this?
It does do anything, but okay. I will share the answer. Because you see, everyone is still used in the world to think about in asynchronous. It's not in synchronous way. It's not thinking about how you can use something in an asynchronous way. This is a bit of a deep dive, but you need to understand a few bits how a server or a runtime works internally with threads. So there is at port 8080, in our case, there is a thread pool listening to incoming connections. That's what's called the acceptor threads pool in most implementations. So that means if there are coming 3 or 5 connections at the same time with from a client, from 5 different clients, for instance, they can handle those incoming connections. Those acceptor threads then create a new thread with all the necessary information, which actually call here your JAX-RS method. So the acceptor threads are already free, so they are no longer blocked. They are free, and they hand over to what's called the application threads. But the application threads, most of the time, the acceptor threads are very limited. If you have a CPU, a multi-core CPU, let's say with 4 units, the optimal configuration for those acceptor threads is 4, because there can be no more than 4 threads running at the same time. So it does not make sense to have more acceptor threads, more things listening for connections who comes in, because they are not active at all the time. So those application threads, they are scaled of the number of concurrent users, because there we do proper thread scheduling, and you can say, oh, I'm expecting 50 concurrent users, 100, whatever your use case is. So those application threads are running this way. But you have that that asynchronous way of thinking, where they say that you should never block a certain thread for waiting. You have that completable future here. You have that that async. So in the case where I call here with REST client, even in an asynchronous way or whatever, that thread will be blocked at some point because it needs to wait for the result, probably is ready. So they say, well, that's not possible. That's not a good thing. So let's create another thread. And that's why there is here that completable future, because when this is executing, your application thread, which was performing this method, is already free again. Is already available for doing something else. But okay, there is another thread which are doing this. So the idea of that entire asynchronous thing is fine if everything is asynchronous, including database access, which is not the case. If you access your database, that's synchronous. There is no, well, they are working, even Oracle was working on an asynchronous JDBC driver, and they dropped it because they said, well, it's simply not possible to do it completely asynchronous. And you know, Project Loom, all these threads, what you're creating here, they are operating system threads. So there is a limited amount of operating system threads available. So they swap, they are swapped in and out, etc. With Project Loom, for those that heard about it, Project Loom, you will have virtual threads. And a virtual thread, if that's blocked or not, that does not matter at all. So Project Loom is basically a answer to the entire asynchronous way of working, because that is rather complex. You have all those callbacks and completable futures. And sorry to say, but for those who work with JavaScript, if you look there, for instance, in a JavaScript single page application, it can become so complex that you don't know what it's doing anymore and why all those callbacks are and why they are not nicely following each other up, etc. With Project Loom here on the Java, then that will no longer be the case. The only thing where this can be useful, if you ask me, is if you stream data back. Here, you always you say to the response, this is the response, and it is streamed to the client, and that's it. But if you have a large data set, then you might be saying, well, instead of waiting until the entire data set is ready and then start streaming to the client, I can already start streaming the start of the response whenever it is ready, even when the entire data set is not yet completed, is available. I can already start streaming to the client, and then you can see a difference on the client because the client receives information earlier on and can start already processing that information. Again, asynchronous, it's not the easiest thing. I hope that at least some bits and parts of it make sense what I told you. But to be honest, I never use this in any kind of production system, this completion state. This, as you mentioned, to perform something in parallel with some other stuff, yes, that is useful, but you don't need that completion stage here at that level. And of course, the client here, the REST client here, is also very interesting. Okay, we are up for a break until, unless there are questions, sorry, maybe there are other questions around REST client here. REST client is synchronous. So let's say we take like 13 minutes then or something, then we are just 5 minutes for the hour so that I can again take something for my throat, so that hopefully it keeps on going for the rest of the day. Okay, we are back for another hour until the larger break. Should not forget to share my screen now this time. So. Next point is what I want to talk about is a few additional things of MicroProfile. So one of the additional specifications, we have seen two main ones already. We have seen the config one yesterday, where you can read configuration values from external sources. We have seen REST client today, and yesterday also already quickly, because I thought we would otherwise have too little time today, was that Open API on how you can document your REST endpoints. Like Open API is not really doing something useful, if I may say so, useful for your microservice itself. So it does not provide anything for the clients, does not provide any functionality. But yeah, of course, the documentation can be very useful. Maybe I first then cover the other two. Is that server still running? Yes, it's still running. Cover two other specifications which also provide useful for, let's say, operational people, but not for the functionality for the business value. We talked a bit briefly yesterday about observability, that you need to know if your service is running fine, if it's going okay, or that there is a problem with it. So the entire concept of observability centers around two things. One is the data, and the other thing is how to interpret that data. Regarding the data, you have what's called the metrics specification, where it is defined by default what are the available, thought it was apps, or no, it will be vendor. It is vendor, some vendor specific things. That's as exposed data for the outside world. You as a system administrator, you're not going to log into each system, each microservice to check in a log file. Oh, is it still running? Is it still fine? No, those data are scraped together from all instances in dashboards and whatever. This matrix endpoint, you see by default, there are already a lot of information, but there's just the basic, there are some JVM information, like my system load average is 3.6, so it's, of course, it's very low because it's not doing anything. But you also have things around garbage collections at 235 milliseconds in young generation garbage collection, etc. In total, there were 14 times. So you can provide, these are the defaults which are required to provide by any implementation, but you can also provide your own metrics. And those can be also business or application related. One thing that always come to mind then is that you, for instance, keeps a counter with the number of invocation each day to see how it is used. A counter who indicates the number of orders that are processed and those kind of. But basically anything that you find that is interesting to know, you can put in this metrics endpoint. You can read the specification. It comes at the end, it comes that you need to specify a certain CDI bean that implements an interface, and then it's picked up automatically and shown here. For those that think that this is maybe a weird format to present, well, this is the Prometheus format. So by default, all the metrics are shown in Prometheus format. There is also a JSON. Going to take a wild guess now. No, it's not. But if you like to have it in JSON, it's also possible that you get that information in JSON. Meaning, if I guess Prometheus is more or less the de facto standard for these kind of things. Officially, it is a time series database, a database where you store information about some values, like here this number of young generations, and you follow up this value over time. So you capture it every 5 seconds, every minute, whatever you find reasonable, and then you can have that stored in the database. You can see the history of the value, and based on that, you can create nice graphs. For most of the time, Grafana is used for that, which pulls that then the data from that Prometheus database. It's pure metrics. It does not say it's pure values. It does not say is I need to find some value. Where was it here? Is 2.8 is that a good value or a bad value? That means that you need to have some interpretation. And that's the second specification, and that's done by the health specification. And by default, there is nothing much that you need to do as an implementation to say to have that health check implemented. But it can be interesting to say here, okay, the status is up. For Payara Micro, that means that Payara Micro is running, of course, because otherwise it could not respond to this request, but also that an application is successfully deployed. If for some reason your application gets stuck, or when at startup there wasn't, for instance, a CDI validation error and it did not start properly, then the status will be down. This is used, for example, in those Kubernetes environments and the ingress controllers, if a container comes up, to know if it can handle requests. If the status is down, well, it does not make sense to send user requests to that container because it should not be able to answer it. It also is an indication for that Kubernetes, the scheduler of Kubernetes saying, oh, this is down. Well, maybe I just drop that container and start over again. Maybe it was a glitch. You can define your own checks. You see, for the moment, it's empty. I did not define my own checks. So Payara Micro allows, for instance, that if your CPU is more than 80% for, let's say, the last minute or something, then you have a negative check and your status goes down. Because if you know your application and you know that if it is already running for 1 minute at 80% of more than 80%, probably 100% of the CPU, then you know that there is something wrong. And then you can say that the health check, through that health check, well, please Kubernetes kill me and start over again. You can create your own custom check, for instance. The one that I talked about is the default one that you can configure. I have to look up in the documentation how you do it. It makes no sense to try to show it to you now. Another thing what you can do is create your own check. For instance, if you have a database connection, database is the next thing what we are going to talk after this. If the database connection is invalid or goes down, meaning that you cannot reach the database because of the database is down or there are network issues or whatever, that you also use in the negative check outcome, and then the status also goes down. So it's up to you to define if the health is of your microservice, of your instance, because it has nothing to do with the microservice, but it is used most of the time like a microservice. It's up to you to interpret your data, your value, if it's correct or not. And you can do it here with health, or what happens, you can do it based in Prometheus or Grafana. You can also send out their events. Based on this information, you have both in Grafana and Prometheus the possibility to send out events. And that event can also be that you get a mail saying, oh, service XYZ is having a problem, please do something. And then, or the system admin gets a text message because maybe it's during the night that there is something wrong and that there needs to be taken some action. So these are the two other useful things, but not for your business case, but for operational things, which are in MicroProfile, the metrics and the health ones. Not going to more in detail, you find documentation about that, you find examples. So if you're interested in that. And yeah, it's unless you are doing DevOps, of course, because then the developer is also the operational person. It's not really related to development. Another one which is useful for the developer is what's called resilience, fault tolerance. We have seen there with REST client that we can call a remote service, but that remote service can be under our control, but can also be external. So we have no idea if it will succeed or not. Or that there is maybe a glitch, as they say it here, a network glitch or whatever, or a timeout because it was overloaded, that service or whatever. So these are some annotations. So you can make that your functionality, your action is retried, is an alternative is found or whatever. So you can, because the idea is that at least your user should see something and just not wait for minutes or at the end just receives an error. There was some error somewhere, but the user does not care about it, so that you get some meaningful responses. These are not strictly on the XRS methods. You see, there are CDI beans, classes, and methods, because these are interceptors. Remember that I mentioned interceptors during the CDI in the first demo that we saw yesterday. By annotating a method like this, with retry, if there is an exception that's happening, and that can be also your business exception, so be careful before you retry something. You see here the third one, only retry on an IO exception. That means that a file could not be read, for instance. That can be a glitch, that can be temporary, so that's something that you can retry. but don't retry blindly, knowing that there is no external access here within that writing service, for instance, because then that does not make sense. There are some defaults. I think max retries is 3 times, and I'm not sure about the time. But also it can be possible that you only retried 5 times, but that it was already 1 second that the initial call came in, and then there was no decent response from it, and then it gives up. It does not keep on retrying, of course. You have also, which is most useful in that retry, it's called fallback. Is it somewhere here, fallback? Most of the time it's used with retry. Fallback is that, okay, we retried this name service. It did not properly respond. So don't try it again and just execute a handler, fallback handler, which gives you an alternative result. Most of the time, it is what you see on the screens. This service is not available for the moment, and but at least you get something that the user sees, responds, and he is informed. Another thing is timeout. Can also be used, then of course with that fallback if this creation of the connection, but I think more useful is the retrieval of a value from a remote service. If that takes too long, then don't wait for it to complete, but do something else, or either return an ULL or do a proper fallback with a constant, or even fallback with a cache value. That's also possible. That retry, sometimes well, most of the time a retry is needed because you call a remote service and HTTP and network can be there, but can be flaky, as they call it, or you are just upgrading your system. New routing is in place, new version of the service is there, and then a retry is of course useful. But there is also what's called a circuit breaker. It's a bit, well, I find it a bit difficult to understand what all those thresholds mean and the failure ratio, etc. I have an example for that in my MicroProfile training. But the idea of circuit breaker is that you try it and it works fine, but when it fails, then it captured that failure. And if that ratio of failures becomes too high, for instance, it works 1 out of the 4 times, it's maybe okay. But if it already fails 3 times in a row, then you say, well, probably the 4th time it will not work either. So don't try it anymore. It's like a circuit breaker in your house, the electric circuit breaker. It jumps to off and you don't try it anymore. So you immediately go to the fallback or saying that is not accessible. But you have there then a delay. Then you say, well, maybe after a few seconds, minutes, whatever you configure, after the delay, let's try it again. Maybe it is fixed now and it works again. So this is the circuit breaker is one of the most complex ones to understand and to explain and to see how it works. But it can give you the opportunity to say, well, don't try to call this remote service because I know it will probably not work. So don't try it at all until a certain time later in the future. If it succeeds after that delay time, then it comes in a temporary state. Then, and if that's success, if it's successfully called again, that success threshold says, okay, we are back to normal business. We are on again. We are green again. And everyone can use it again. Bulkhead is to prevent overhead. So you are providing a service to the external world, but that means that, yeah, probably you can have some denial of service attack. Bulkhead will prevent that by saying maximum 5 requests, 5 threads can access this method at the same time. If there is a 6th one, then yeah, that's just rejected. Be careful, of course, that you configure that value properly, because if you put it too low, then you can have an exception also with normal usage, that you add that no attack is going on, but that's something that, of course, that you need to know about sizing and dimensioning of your system. Instead of just saying, well, if the 6th one comes in, then reject it, you can have also a limited waiting queue by putting here asynchronous, and then you can actually say, well, we have a waiting task queue list. So 5 requests can use it at the same time. If they're coming in more, they are coming in the waiting queue, and everything is in a separate thread pool executed. Again, if then number 5 plus 8, that means if number 14 comes in, then again, you have an exception. So that's important. Fault tolerance, because I mentioned already, microservices means you're in distributed environment, and you have what's called the the number of fallacies for distributed computing. For those who does not know, read it. It is a good thing. If you have a microservice environment, one of these 8 things will bite you at any time. You will have an issue with one of these 8. So be aware, again, if you are using microservices, that that you need to take care in those, take care these 8 factors. Any question about? Yeah, the last one, what I of MicroProfile is the MicroProfile JWT authentication. It's about tokens that you can pass on JWT tokens in the header, and that you provide the user information and the role information and whatever in the token. The nice thing about that is that for validating if a token is valid, you don't need an external system. You only need the public key to verify the signature of the token, so that you know that the token is an authentic one, it's not a tempered one. And that means that for a microservice environment, that is essential, because otherwise you have one central system which validates your sessions or tokens, and then that can get overloaded, and then you have again a bottleneck. These distributed checks with JWT is nice, is good there, and actually it is based on what's called the JOSE standards, the JavaScript object signing and encryption thing, where everything is described, what is a token, what is required, etc. So that's probably a full day on its own to explain that in full, because it's also cryptography, it means that it is not the easiest thing, but it's a fun thing which I very much like to do. Any questions about MicroProfile? Because about those metrics, health, or one of the other that we discovered, because we are moving on to databases. Okay, I see no questions. Okay. This is all we covered, JWT, so data access. As I already mentioned, yeah, data is vital for any kind of application. Otherwise, we don't have an application, if you ask me. And there are classic ways of storing and retrieving your data. So I'm already presenting NoSQL solutions as a classic solution because they are used a lot in a lot of situations, and there are valid cases for not using a database and not just using tables and fields and rows, but for instance NoSQL with you have the key value stores, which is basically a hash map. It's a bit yeah, it's a bit short to say that, but okay, basically it is a key and hash map. You have those graph databases. I know there is someone here who is a fan of Neo4j for graph databases. So you have all kinds of solutions to store your data. One thing, and that's coming as the first thing of this afternoon, is yeah, all those systems are external to your JVM. Your application, your XRS resources are running in the JVM and can access Java object, Java instances, and need the data there to return it to the user. But actually, all our data, we store it external in a database, in a key value store, or whatever external solution to keep your data as, let's call them a data storage external. So the idea of MicroStream is that your JVM memory is the database. The only thing that you need to take care, you need to consider then, of course, is that when you stop your Java instance, that your data are not lost, but can be recovered. Let's say recovered can be loaded in memory again when you start up. So that's what MicroStream is all about, and that's for this afternoon. And in which scenarios you probably can make use of it instead of just a database, where a database or a data storage in general is probably not the best solution, but something like MicroStream is better. But database has its values. So let's talk about how you use a database with Payara Micro and use JPA. At the JPA, the Java Persistence API, is what it's called a ORM standard, a object relational mapping. So you see, you need to map your Java to how you are going to store it external. And through that mapping, through that ORM, the framework from JPA, you have the most common one is Hibernate and Eclipse Link. There are two implementations of JPA. They know then based on that mapping, working on top of JDBC to retrieve your data from the data store or save it to there. So why are we using something like an ORM and JPA and not plain JDBC? Sometimes it is better to use just plain JDBC, but with plain JDBC you have quite some overhead, some boilerplate as they call it, because you do really low level access. You need to deal with a connection to the database. You need to deal with what's called a results that with a managed statement. So you're doing the real low level stuff. Mostly, I'm not going to say at the byte level, but that EAP, that JPA and that ORM gives you a higher level, an abstraction, which makes it easier to work with. but of course has its pitfalls. Because sometimes it can be quite challenging to retrieve the data with an acceptable performance. You probably have heard already about the N+N query problem, the caching, and that you start caching the data because it takes too long to retrieve all the data. And then, of course, you have the mapping itself. You need to write the mapping. As for a simple situation, the Hello World things, that's perfectly fine to do a mapping. Everyone can do that. But when it comes to more complex ones, parent-child relations, abstract hierarchies, where you try to model your inheritance that you have within Java, you try to model that to your database, then that can become complex and challenging. But the first thing for JPA requirements, as from the explanation, it should be clear. You have the ORM tool itself. So Payara Micro uses Eclipse Link for that. You can use Hibernate if you like that. It is possible to make that switch because Hibernate and Eclipse Link have besides the standard of JPA, they update, of course, and they've implemented a few of their own functionality. So there are a few differences between Hibernate and Eclipse Link. And yes, what I see, the world seems to prefer Hibernate in most cases, not Eclipse Link. So it is possible, but by default, it is Eclipse Link within Payara Micro. You need a JDBC driver, of course, that's not included in Payara Micro, so you need to specify that. And then, of course, you need to do the configuration. Where is the database located? What are the credentials? What are the configuration options? So let's have a demo to see that in action. You know, that's always more fun to show it in action. Yeah, the idea of Payara Micro is also that you don't include your JDBC driver within your application. You specify it as a configuration parameter on the command line, but don't include it as a driver. It is possible, but you don't need to include a driver within your project. So that means that we can create an entire application by just having this dependency here, which we had already all the time in all our examples with the web API. Scope provided. What is needed? Two things. As I said, the ORM tool, Eclipse Link, that's by default there, so we don't need to do anything. The other thing is the configuration. And this is there are, I think, even 3 ways of configuring a database connection with Payara Micro, or three different ways in Jakarta. But I find this this one with the data source definition the most easiest way to do it with Payara Micro, because it is just an annotation. You specify the annotation there, and you give it all the requirements. For instance, you need within Jakarta, you need to specify a GNDI name, the Java Native Discovery Interface, I think it is called in full name. So once that you have put your connection, because you actually put a connection in that GNDI service, in that GNDI registry, then any part running on that same JVM can request that by using this name. And we will see that in a moment how we requested them for JPA, because this data connection is actually not part of JPA, so we configure the connection outside of JPA. We need to specify the driver name, and so that Java knows how to connect to your database. So that's specific. There is Well, there are standards which call JDBC1 type, JDBC2 type, etc. But how the communication happens between Java and the server, the database server itself, is not standardized. So every vendor has his own protocol. The only thing that they follow is then, of course, those JDBC things as a connection and as a prepared statement. But how that is implemented underneath is vendor specific. So that means that we need to specify a vendor specific class name. In this example, I'm going to use MySQL, but of course you can use Postgres, you can use any kind of database. Besides the database data source or that vendor name, we also need, typically we need to know the URL. The location of the database is also called some kind of URL, username and password, and the pool size. Again, you can have multiple connections prepared within the JVM. Well, not the JVM, it is Payara Micro that provides that pooling, so that when your application needs a connection to the database, then it does not need to create it at that moment, because there is quite some overhead. And then, well, I'm speaking about like 150 milliseconds of creating a connection. And to avoid that, there are already connections pre-created and ready to use in a pool. And I define here the pool sizes between 2 and 4. Again, you need to adapt it to your needs. And yeah, this URL, username and password, that depends again on the environment. So that needs to be configuration. Payara Micro supports, because that's not a standard, because the standard does not know about, Jakarta does not know about MicroProfile. But because Payara Micro combines the two, Payara Micro allows you to specify these values for the URL, username and password as MicroProfile config values. And you can do it by using this prefix here saying this ds underscore URL is not a string, so it's not a URL, but is actually a key that needs to be looked up by MicroProfile config. If there is anything that you want more information about, please interrupt me, because otherwise I'm just continue with the basic things, with the basic explanation. Probably most of you know that, but I try to put in some Payara Micro specific things in this narrative. Then this is the configuration for your JPA. So that says there is a persistence unit. There is the definition of the unit that is capable of persisting your data externally. And yeah, you can specify each classes. You can specify the classes where the mapping is created, or you can specify the XML where the mapping is done. But most of the time that's discovered automatically. You don't need it to define it. You just specify a name, because you can have multiple persistence units, and then you need to, because you can have connections at the same time to multiple databases. And of course you need to say encode which connection, which database, which unit you want to use. But if you have only one, then yeah, it does not matter, of course. But here important, of course, is the database, the data source, where is it connected to? And this name here, if you remember, that's the same name that we have used here in the GNDI, name of that data source definition. And we have a few properties. Which is something, one of the properties is that you should not use in production, drop and create. So that means when I start my application, that it drops the entire database. Don't do this in production. But of course here for testing, that's very convenient, very easy. You can have a database created automatically. There are tools like Flyway. Maybe some of you heard about it. Tools like Flyway to populate your database in a certain state, etc. if you are a fan of that, if you are using that, yeah, that's fine. If the project that I did, I just created the SQL to update the database and put it as a resource in my source folders in a specific source main SQL, so that at any moment you can just execute those SQLs and your database is up to date. I'm not always fans of those flyway alike tools, but they work perfectly. So feel free to use them and perform the steps that you need to do to keep your database updated. Here it just drops and creates it. So this creates only the table. So I also specify default data. So I have a few insert statements here. So that means that yeah, at startup this script is loaded, but again, I only use it in demos, not in real-time production. This is sometimes very useful in development, that you see what Eclipse link, in this case for Hibernate, there exists a similar property to actually see what it is doing, because as I said, you really need that when you are doing more complex queries. See what query C performs if you don't have that n+1 select query, etc., etc. So this is probably a must-have property in development. And yeah, you can again put this as a microprofile config value, because you can also use here microprofile config within Payara Micro. So this level here, finest, or in production, you will then be having something like severe or warning, so that you only see the warning errors in production, but so that you can configure it depending on your environment. A basic mapping. You need entity. Each entity needs to be implementing serializable for the ORM tool. You need to specify the table, and then of course for each Java variable, you need to specify the field name to have a correct mapping. This is the primary key. An entity in JPA always needs a primary key, so you cannot have a table without primary key within JPA. Sometimes that is a bit annoying. Most of the time, yeah, it's naturally to have an ID, to have a unique identification of your record, and that unique identification should not have any business value. So don't make, for instance, the email address of a user the primary key, because when the user wants to change his email address, then you're in trouble. Because yeah, a lot of other tables probably refer to that value of that primary key, and that means that yeah, you have to do a lot of things to make it working. That's the reason why there is something like this, a generated value based on a table, or for instance, Oracle, you can base it on a sequence, or I think it's Postgres, or is it MySQL, that you have a native incrementing value within the system. So use something, just a number, no meaning at all, but it has the possibility to uniquely identify a certain record. You have column. You can here again specify, but the length is 25 without string, then of course. That means that I cannot add that the database will have a length of 25. That can be useful because JPA automatically checks if there are no constraint violations. So if you put something that's longer than 25, you try to insert it in the database or update it in the database, then that will automatically fail if the length of that string here in name is longer than 25. And then you have an exception within JPA and not the database. It's fine, but again, you are duplicating information, you are duplicating functionality. The database is already doing it, but you are doing it again. Yeah, it's good, but sometimes I think there are better solutions. How do you read and write from such thing? So that's here the company service. That's through what's called the entity manager. The entity manager has a few methods. For instance, it says find me. One thing that I need to say, entity manager works on Java objects. So that means if I say here, find me a company with that ID, then he actually looks that up first in his transactional cache or secondary cache within Java. So everything that entity manager does is on Java objects. Later on, if it does not find it, for instance, the find sees, oh, it is not in a cache, then the entity manager will create an SQL query for that and will retrieve it from the database and put it in his transactional cache for at that moment. But important to know, entity manager works on Java. So that means if you create queries, and believe me, a lot of people struggle with that. If you create queries, they are not database queries, they are Java queries. So I select C, and C is analyzed for company for that, and I want to have to all the companies. Again, he first looks in his cache, does all the requirements there, and then if it is not finding all the information, then it goes to the database. Why I say that is because a lot of, well, not most people, some people struggle with it, because here you can say that, for instance, in your database field is called company name, but your Java name is name. So if you do then here, where C dot company name is equals to some value, then the query does not execute, because entity manager at first don't look at the database, but looks internally based on the Java names. IntelliJ helps you by saying, hey, company name, I don't know that. If you put name, he will not say a red flag, and it still says it because I did not update probably my my per project. But that's very important to know, very important thing to remember. Entity manager works on Java, so everything you put here in queries is not SQL, but is a query. It's called JQL, JPA query language, or HQL from Hibernate query language if you are using Hibernate, but it is Java. Inserting is then, say, persist me a company, and then he will perform the insert. That's a basic thing to get started. How do you get it up and running? Because I still have it here. I still have it here. We are not done, because I said, well, the database, the JDBC driver is external. You need to provide it externally. I said here also this MicroProfile configs, I should provide them externally. So what is then the actual command that you need to run for Payara Micro to get this example up and running? So that's in the definition, and it's like this. So you know this, Java Payara Micro.jar, and then you say add libs, so add additional libraries, and you add the you specify there, in this case, add the MySQL link. So this is this is where the JDBC driver for MySQL is to the path, and then it's added At runtime, with some tricks, the class path is extended. This all jars at libs is added to the classic Java class path because yeah, there is some dynamic things going on when you start a Payara Micro. This you also know, the .war file that you start, and then this is the system properties. You remember that MicroProfile can read values from system properties. So you can specify additional system properties, which are loaded also dynamically by specifying this path. So that means that the s_URL is then the URL of my database, my username and password. Yes, I don't reveal my password for everyone and in the recording, so I created something which is just my username. So this is the URL, how you can start it, and then everything comes together and work together. And hopefully I have saved it here. Yes. So I'm using Docker most of the time to run the databases, because that means that I don't have to install it locally and start it up, etc. So I'm running Docker here for MySQL. So that takes a few seconds to start up. And then I have MySQL running. Next step is I'm launching my application with that libs and the system properties. Hopefully the database is ready now. So I can start the Payara Micro. He will then drop the database, which was empty, but okay, then he creates empty tables. He does all the inserts. You saw maybe quickly here. Here those inserts that's happening, insert into, because I set that level to finest, so that or fine, so that I get all that information. That's all looking good. So read from one table, very simple. Here is I have a free screen, and I get my information back as JSON from the database. And you see also which query he performs. So he performed select ID, name from company, where ID is then, and one parameter bound. You can also specify a second option in here in that in that persistent, sorry, to also print out then which parameter, because yeah, now it was easy. It was just a parameter from the URL. But in real world, it is probably some calculated value more complex. So you can also print out then the value of that parameter if you like. You can have master detail relations. An employee can be parts. Yeah, I forgot to mention transactional. Transactional is the way that go back to that to that company. I just say persist. But databases are transactional. That means that a change that I make is not immediately visible, or if you by default, I guess all the database will use it like that, that something which is persisted is not immediately visible for other users. So you need to close your transaction, you need to commit it. By specifying here transactional means that every time at the end of the method, that's again an interceptor, a commit is performed so that this insert actually happens. If you look closely, for instance, as I again said, this persist is the entity manager, so that's Java. If you, for instance, go to debugging, if you stop at each line, you see that after doing this persist, there is no insert emitted to the database. That's only done through this transactional, because then he sees that yeah, what's called the dirty checks, because all these companies are actually proxies, or not the actual class that you define. So there is a lot of, let's say, hocus pocus behind the screens for the API to make all those things work. It also has this impact on performance, of course. Application, And here I say, select me from employees. So I want to have all employees, but I also want to have the company information. See, and then I need to do already some specific things that he also needs to fetch the company information for that employee, because they are in different tables. So he needs to create a joint SQL statement. So if I don't do this and I try to read the company information afterwards, then for each employee, he will go to the database again to fetch the company. So that's the n+1 select problem. So this avoids it, for instance, joint fetch. Is that n+1 select problem a real one? Yes. I was once called, and it's already 15 years ago, something, for a project saying, well, when our homepage of our application shows, it takes around 15 seconds before it shows. Why? We don't understand it. Well, it was rather simple. It executed 1,500 queries because of that n+1 select problem. It did not need it at all of them, but yeah, for other parts, they need the information, but for that homepage not, and they reuse it, etc. So yeah, there were 1,500 queries executed just for showing a home page of the application, which has basically a few basic information things about that user. So it is a challenge. I can say you that to define it, and here in the many-to-one, you have here the many-to-one. There are several options to make it lazy, fetch eager, or lazy, and those things. And eager is good because you fetch it in one time, but it probably loads too much data. But if you do lazy, then you don't have the data when you need it, etc. So it's a challenging task. Here, of course, it's quite simple. If I ask for all employees, master detail relation of this one, if I call them here, yes, I get the information fast and easy because it performs to do the fetch join. It selects from two tables, from the company table and the employee table at the same time with all the information. Again, you can have converters because for funding, I created, yeah, there are default enums. Well, default, I mean enums that are handled by default. It's not here, it's in employee. You say that this field is not a normal field, but is enumerated. You have two options. You can either specify the string value of the enum or the ordinal value. And remember, enums has an ordinal value 0, 1, 2, or a string value, male, female, other. Annoying thing is that by default, it takes the ordinal number, which means if you do something like this, you change the meaning of the data in the database, because the database has only 1, 0, 1, and 2. If you just reorder this, then yeah, you change the meaning of that value. So don't do that. Don't, for ease of working, always say enum type of string. You use a bit of more space because it actually writes then the string text male, female, or other in the database, but at least it is future proof. That's the enum. But you can use custom values. I have here a color. A person can have a favorite color. I could not find anything more useful, which was easy to implement. And then, yeah, you need to have a JPA converter, which converts your Java class to a string and from string to Java, because you have two ways. Since we also do it for JSON, I have here also added a serializer and deserializer for that color to JSON. So I created here a color converter, which is actually reused for that JPA converter also. That converts again from color to the actual string, to string and back to the actual color. See, it's more or less the same as I showed you with JAXRS, but now it is reused so that I use it for the JPA and color serializer and deserializer. So with a bit, if you think a bit about what you're trying to do, then you can reuse a lot of things. If they are the same, of course, because if the client say, no, I don't want the color format as red, column green, column blue, yeah, then you have another issue. So that's a bit of JPA, short thing, because JPA is a large specification. Probably again, also a full day if I need to explain everything, but I guess most people know JPA. So it was mainly about how you can do it with Payara Micro, so the system properties, the additional library that you spent with the JDBC driver, and here then the data source definition, which is a standard Jakarta one. You see it's in Jakarta Web API, which I find the easiest way of the three possible solutions to define a definition, data source definition for Payara Micro. Any questions? Because we are almost done for my morning, and then we have the break. And after the this afternoon, I'll show you how you can avoid all this mapping, all this external retrieval of data with MicroStream. But first, are there any questions here around JPA? Okay, good and not good. As I said, I like feedback discussion, but it is what it is, and it is fine, so that we can all have now our long break. So I see you all back in an hour for the second half of the day, and that's then MicroStream. That's an integration testing and Docker and a few things around those technologies. So I hope that everyone is back behind the screen for the last half of the workshop around Payara Micro. There's still two topics to cover. One is MicroStream as an alternative for storing data, and the other one is integration testing. And then at the end, we again have that exercise or a discussion or whatever you like to spend as that last minutes on this workshop, of course. So if you remember in that Jakarta hands-on that I reviewed this morning, I used a database. I called it a database, and I'm using 3 lists of data there: a product, a user, and the items a user has, the products that the user has. It's just retrieving them, adding them. So there is not that much functionality because that's basically what we can see as a database. But for instance, here I showed you the filtering on the products. And this is something that every Java developer can write. Okay, he needs to know about the Stream API and how you can use it, and a few things about lambdas. And but everyone is familiar with Java. And of course, retrieving these data, it is a rather small data set, but retrieving these data is very fast because it is just in memory. All those JVM instances are there in the heap. We can access them, and we can find the product by ID, by those criteria about price and category. So that's the idea of MicroStream. Also in that JPA example that we have seen, if you need to provide a response for the user, yeah, the first thing that you do is looking into memory and access your objects there. If they are not there, then you have to search them externally, like for a database or any other data storage. But with that database storage or any NoSQL solution, yeah, that external solution and the external storage, the database, the key value map, for instance, that's the primary. So the external source is the primary source. And yeah, Java is a bit a second class player there, and yeah, we just retrieve the data that we need to return it. But yeah, the application is running in Java, so why don't we just say that the database is the Java memory? This list of this instance here with the list of product user and user items, what if that is a database? We can query it, we can update it, we can add it, we can delete the data, and we all know how to do it because we can write Java. We don't need a mapping.
Sorry,
we don't.
You need to reshare your screen. We cannot see at the moment.
Every time we have a break, I forget it.
Thanks.
Luckily, I did not show anything new, only talking about this is the database. So you can follow it without a screen, but okay, this is the database. And this is the primary source. Everything else is secondary. We don't need any mapping, or in ideal situation, we don't need any mapping. We don't need any SQL protocol or any other kind of protocol to transfer data between the primary and the secondary thing. That works fine. There is one problem. What if our instance stops? If we stop our instance, then of course the heap is gone, and we lose all the data, and we need to find a solution when we start up to retrieve the data again from somewhere. But let's keep that first in mind. Let's keep in mind, let's make the database as the primary, the JVM memory as primary as the database. And as I said, we need to find a solution because data needs to be survive a process restart. So we have something what's called in MicroStream a storage manager. But let us first have a look why we are thinking that the JVM heap should be the database and not the database with tables or a NoSQL solution, especially if that external system does not provide us any benefits, because I assume in 99% of the cases, you are using a database just to store data, and that's it. You are not using, you're not doing anything else with it. Yeah, for retrieving data, but not for performing any logic. There are a few exceptions, but most of the time, there is no additional functionality provided by the external system. So as mentioned, we have that object graph. We talk about a lot in MicroStream about an object graph. And that's the interconnection between all the, or not all, because you can have multiple object graphs, but you have most of the time a large object graph depicting your data. For instance, that database, it has a list of products, user and user items. They are linked to products and a few other lists. There is several instances of product, etc., and they are all linked together. So you have a complete object graph in memory. And that's what's called the impedance mismatch. If you can look it up, it's well described that in 2 words, it comes to this. This object graph is not at all the same as the tables and the fields and etc. that we have in the database. That's, for instance, the first reason why there are NoSQL solutions, so-called NoSQL solutions, because in several cases, it does not make sense at all to put something in a table and a field in a row. We try to force it in that way and try to find a mapping and do whatever we try, what we can to put it there, but there is a mismatch. There is what's called a mismatch in granularity. Here we have a lot more fine-grained information in an object and the relations, which most of the time we cannot find in the database. Yeah, subtypes, mismatches, because the types of database, what is supported, yeah, okay, we have string and numbers, etc. But as we saw, we have there that RGB or that color class, and then we need to create converters because the database or the other external system does not know about those Java types. We have also what's called association mismatch. Many times in your object graph, you have a two-directional, bidirectional information between parent and child. Child has a link to the parent, and the parent has a list of childs. In databases, it is only one link, and you only have a link from the child to the parent. So retrieving for the parents all childs, you can do that via select query, no problem. But yeah, you need to do something specific, and you need to query to those both tables. Then. And if it's now the database or a NoSQL or whatever, but what if we could just store this entire object graph somewhere? What I prefer most is that we store it just in plain file storage or a volume or whatever, because you can store that binary also in a database. If you serialize the entire object graph, then you have a stream of bits, 0 and 1, and you can have a blob, a binary large object, for example, in a database, and you can store it there. But databases are not very well suited for that, for those large binary objects. But hey, you can do it. So many people are familiar with database, so you can, for instance, store that entire object graph as a binary format in that database. A file, binary files, of course, are much more common, which means that if you somehow, and I come later to how MicroStream does it, because it's not the standard Java serialization, if you just store the entire object graph natively as a binary representation externally, files or database, or S3 buckets, or Hazelcast in memory data grid. That does not matter. But you store it somewhere where it can survive the restart of the process. Then we have solved also that problem. Then when the process starts again, it just reads the entire binary format again, and it can recreate the entire object graph. And you have again the same, at least that part of your Java heap memory. You have again the same situation when you stopped your application. It saves a lot of CPU, well, because that's the idea that serialization is easier, and thus is easier to implement, is faster to perform, so that serialization is faster than performing the mapping and performing the queries and the insert and select statements. But most of all, every time you need data, it is there where you need it. It is because that Java heap is considered as the primary source for your data. It is a database, so that means you have no latencies. You can create queries. You can use get methods. You can use any kind of functionality that Java provides to provide you with the data for the user's request. And that's what MicroStream does. It's just its main purpose is to serialize a certain object graph to an external storage, so that when you start again, that you can retrieve it. As I said, it can be the database, and apparently a lot of users prefer the database because they are familiar with it. And if you store it in the database, if you do a backup of that schema, then your data is also automatically backed up, and etc. So and databases are still probably needed for a lot of situations. I don't say that MicroStream will completely replace the databases, but there are many situations where it is more suited. Besides database, you have also NoSQL. I mentioned already that Hazelcast, but you can put it in a Redis cache, or MongoDB. You can put it also there, as I mentioned, S3 or any kind of blob storage, as long as it can handle a set of bytes, a long set of bytes, then we can store it there. MicroStream has an open source version, and you can find it on GitHub. And there is also a private version for enterprise users. Some of these, what I mentioned here on the slide, are only available for the enterprise users. Not everything is available for free for everyone. Although the idea is quite simple, that's with most IDs. The idea is simple. Just use your Java objects as database, and just make sure that there is some kind of serialization. There is a lot more going on and much more needed to have a fully functional product, which is versatile and can be used in many situations, of course. Let's start in the middle. There are two flavors of it, although Android is running on Java. It has a specific, there are some specific types for Android, of course. So there are two flavors of the what we call the persistence engine for the JVM. One is purely Java, but meaning that's pure Java. It can also be used for any JVM language. We have examples that you can use it with Kotlin, with Scala, etc. Because it is just JVM language. all those classes are interoperability. And then slightly different version for Android. But all the rest is just pure Java and is used for in all situations. That persistence engine that uses a serialization, a custom serialization. So we are not using the Java standard serialization for two reasons. Well, no, there are more reasons, but there are two main reasons. And one main reason is that, as you know, for Java serialization, you need, for instance, to implement the serializable interface. Without that interface, you're not able to save in a binary format your data. And since we wanted to have something that's usable in all situations, not only for a specific set of classes, because then probably some classes from the JVM itself, or some classes from a framework, a third-party framework, a library, cannot be used in that object graph that is serialized. That means then that requirement of that serialization would limit the usages that we had in mind. The second reason why we did not want to use the Java serialization is because you also know it, the Java serialization has some security issues. In the latest versions now, I think it was since Java 16, you have the possibility to have some of those serialization filters where you can say, I don't want to have this kind of class in the binary stream, and if you encounter that, then just reject it. Because otherwise, if you just provide a Java serialized format, it can read it in, because Java serialization format contains the data, but also some class information. So to have the class structure, and it can recreate a lot of things without actually having all the bits and pieces of that class available on the class path. There are, of course, some checks and limitations, but as you know, there are a lot of known issues with the Java serialization. So the microstream serialization is something created from scratch, built from the ground up, pure Java, which only contain then the pure data in that binary format. I can show you in a moment with the examples how it solves those things, or at least give you some hints, because diving into the entire code base would take us a bit too far. There is also a file system garbage collector. I'll tell you a bit more in a moment in the example of what that does. And we have what's called a file system abstraction. Because the initial idea was indeed we store it as a file. That makes most sense. But then, as I said, people also wanted to have the database. So actually, there is an entire abstraction of a file system. It's called AFS, Abstract File System, within MicroStream. And you can have any kind of implementation. There are 2 or 3 by default in MicroStream. The file system have the disk on or the network drive that you have in your system, but you can also have a implementation of that AFS, which stores then the information into a database. So basically, the serialization itself and that persistence engine only works against that abstract file system, that abstraction. So you can implement any kind of storage that you like, that you see fit, or as most people do, just use the default one which are available. There is also a backup possibility. We are even working on other kinds of solutions. I'm not going into all of the details of that, but going now back to the top, we need to have some kind of capability of moving forward, because today you have in your version 1 of your application, you have an entire set of Java classes, but application evolves, and tomorrow you need an additional property in a Java class. You might even drop an entire class and create a new class for it with a new class name, with a new structure, etc. So there needs to be some kind of type mapping. We call it legacy type mapping, legacy from this old, meaning it was the previous version. Because yeah, you have your old data serialized to disk, for instance, but you certainly want to read those data back again, of course. Whoops, that was not the intention. So that's that legacy type mapping. There is some automatic things in the background. It tries to figure out if there are changes. For instance, if there is a property added, or is there a new enum value, etc. That those kind of things it can figure out itself. For the more drastic changes, you need to provide the system some hints and some actual guidance on please convert a old person class to a new person class, for instance. Everything is binary. Your JVM internally is binary, of course. Your application can handle it and it can create responses. The storage in the file system is binary, so you cannot really access your data. You cannot see it anymore, and that's, for a lot of people, that's a bit frightening, because it is there and I can use it, but I cannot get my hands on it. I cannot see it. I cannot export it. I cannot handle it properly. For the moment, we have already a REST interface. So you can activate a REST interface, and then you can consult the entire binary structure of that serialization. So you can see what is stored. You can see the class references, the class instances, and all those things. You can access them. And then there is a storage browser, so that you can, in a more graphical way, you can click on the references, and you can explore it like that. More things will come in the future. We are thinking about more ways of exposing that internal data in other formats. You can already export it, but it's a bit awkward sometimes to export data, because how do you export an entire object graph? You cannot do that in one single CSV file or Excel file, etc., because you have so many different types of formats and layouts, etc. But it is possible to export it to all those formats, and we are working on other types of viewing what is there, just for the purpose that some external systems might also need to have access to those data. So that are the concepts of MicroStream. So idea is that your object graph with one single root object, I come to that in a moment, one single root object, that's the point of the entire persistence, the entire serialization, which is a custom one, which is binary, it can be stored to file, and there are a few things around it, like that legacy type mapping. Any questions already about what I'm telling about this principle? Okay, let's dive into some examples, then it become probably much clearer. So you need just a single dependency. We call it the embedded storage. and that word embedded does not mean that it is, well, it means that it is just running at the storage is running within your JVM. It does not mean that the serialization the final byte stream is only available embedded or in embedded devices like or on Android devices, etc. We call it embedded because your data, your storage, that's the database, is within your JVM. Since version 7, we also added some SLF4J log statements so that you can see internally what is going on. So you can see when certain subsystem starts and what is doing, because that previous slides that this previous slide that I showed, that's are the main parts. Let's say that's there were 6 or 7 subsystems. In total, there are 15 or 17. They are all configurable. They are all interchangeable, even with your own custom version. And so if someone wants to create a custom version of it, that's all possible, but defaults are most of the time fine. All that information is more available with the debug, at the debug level, what it is doing. So that's the reason why I put here SLF4J simple, so that we have an output. If you just remove it, it works fine, perfectly fine. You know, SLF4J just says then that it does not find any binding for the log statements, but it does not affect the functionality. One of the examples here does a persistence of the data only. I will just tell you the difference. And then to access that, you need that the additional dependency. Most of the time you don't need it. So you only need to have this one and concentrate on that storage manager, because that's one of the central points. You as a just a, let's say, simple user, as a normal user, as not a advanced user who wants to tweak every little point, then you only are confronted with the storage manager, as you can see here. There are 3 different ways to configure that storage manager, and this is the simplest possible one. You have 2 other more advanced versions where you give more information. One of them at the second level I'm showing in the next example. But first, concentrate on this one, where we say, okay, the embedded storage starts. So at that moment, we can store a certain object root to disk, and we say that it needs to store it in the target directory and the target/data directory of our project. All the rest are the defaults, but it's enough. It works like that. And yeah, as I mentioned, the only thing that we need to specify is a root object, because when you have a object graph, most of the time there are some circular dependencies. So there is no beginning and no end on a object graph. Sometimes there is, sometimes not. So to avoid that uncertainty that the system knows where to start, because if there are circular dependencies, then at the end everything is accessible at some way through one of the links, every object. So we need to give the system a certain root instance. Here, for now, it is just that that content, just a string. But think about more. Keep already in mind that basically what we are trying to do is that this database is the root. That's a single object, and all that information is our data in our data storage. So we give it a root object, and everything within that root object will be handled by microstream. We create a new instance here. So that means that initially we have that structure, but it is empty. There is no, the string is empty. There is no value. And we can print out the content from the last execution or the initial value. So that will be empty. Then we can set content, and then we can say, well, store me the root. That's an exceptional case. More on that in a moment. And we can say, oh, this was the content now of our root, and then we shut down the program. You can call the storage manager shutdown. You can call storage manager. No, it's because out of that try block now that it does not find it anymore. You can also use close. That can be useful, especially if you are having multiple storage manager, because you can have multiple databases. But actually, that's not needed. From the moment that you have called store, in this case, store root, everything is stored to disk, and you can even crash the system. You can do a system exit, you can do a Control-C, whatever. You can crash the system, and the data is stored to disk in this case, and that means your data is safe. There is no cleanup that needs to be done, etc. Lazy cleanup or whatever. So the target data is empty. Yes, I will close this because that's from another. I mean, close. I will delete this because that's from another test. So that is in a moment. I have not the old data, so let's run this hello world type of thing. So we run the application. There is no database and no data in our file system yet. You see all those log infos, database content at load time. There is nothing. The string was null, and then we set a value, and we set hello world with date and time. So it was 13:35:08 my time. The second time that I run it, that target slice data already contains information, and you see it is restored. The data is retrieved from that storage and available immediately after we start up the storage manager. So the storage manager sees that there are data and modifies this root to match the data which are stored on disk at that point. Maybe a quick peek of what it does store. Now you see this is the directory. It creates what's called a persistence type directory, and it creates a channel with data, and this is some kind of transactions. It's of course not real database transactions because we don't have database, but I will tell you the analogy from this file. This file is human readable. It means we can try to make sense out of it if you know what it is, because this binary data, I can show it to you. This is purely binary. This is my storage. In this binary data, there is no information of the class to avoid things that we have issues like with the classic Java serialization. Of course, we need to know what it is. If we store something, are we storing a string, a integer, a data root object here? So that's the reason why everything is encoded by numbers. So if the system finds this ridiculous 005s, then it knows that well, it is an integer, and to be more precise, it is a primitive 30-bit integer assigned value that it finds there in that binary format. You see all that information is stored here so that it can decode that from the binary storage. And at the end, you see that there is the data root. So we have assigned a certain number for our custom class so that it knows that if it's reading that data again, it finds this number that it needs to look for a class within your class path with this name. And it has one property which is serialized, which is a string with name content. As I said, this is the purely data, the binary data. It's not much sense out of it, and this is what's called a transaction, because every time we do a save, this file grows. We append adding the new data at the end. So every time we write chunks of data to this file, we log them in this transaction file, because every time we write something, we see it as a transaction. And this file is also consultant to reconstruct the chunks and the bits and pieces, because if we did run it a few times, so eventually, if we run it over and over and over again, these files become large and large, because we always have the new database content that we store in this file. And now we come to that that name here that I said here, the file system garbage collector. That garbage collector is comparable to the garbage collector of the JVM, in the sense that it performs the same functionality. Things that are no longer needed are removed. So we always write new content here. We write at the end of the file, and the file grows and grows. But if we don't do anything, then at the end, our disk is full with old content that we no longer need. So that's that garbage collector that runs continuously and takes some time. You can configure the amount of time. By default, it is a few percent or something. You can configure the amount of time that it spends finding out that, oh, based on these transactions, is there not a old instance of this class that we have now newer data for, and thus no longer needed, etc., and that can be removed. So that garbage collector makes sure that this channel data file is as small, as compact as possible, without compromising, of course, the data integrity, so that we don't lose our data. Questions already about this hello world? See a few people excited about microstreams, so that's good. This store root is a special thing. Normally, you only use store root once, and that is when in the first time when the database was empty, and we assign some initial values to it, and then we can do store root. Don't use store root all the time. I will show you in a moment why. There is a question, is the store data encrypted? No, it's not encrypted for the moment. It's pure binary. So unless you dig into the entire algorithm, how we write it, then it makes no sense. If you see, there is here somewhere hello, probably. No, I cannot even see that word hello here. So you see, it's purely binary. I guess it would make sense at some point that we provide that functionality to encrypt it. But no, it's not encrypted for the moment. It's just a pure set of binary data. Not move. Why does it not move? I just want to have this one. I call it full configuration because yeah, it's what most people do. It's this hello world with just one single path and a route is yeah, is fine for demo purposes, but probably not enough for real applications. So what is the full version? It is this based on some builders, builders for several levels. It can, at least for me, I always say the things that I have experienced. For me, it was sometimes a bit overwhelming, all this and whatever, but after a while, it makes sense. Yeah, first of all, some of the more complex builders, we call them foundation in MicroStream. So we create a new builder, and at the end we create that embedded storage manager from that builder, and we set and we put here the configuration. You can have multiple things here. You can also set, for instance, the root here. And the configuration is then a storage file provider. As I said, we implemented that AFS, abstract file system, and we provide the actual, and this is not a Java one, this is a MicroStream one. This is the mapping between the abstract file system and the real file system of your server, of your machine. And use non-blocking I/O as any good framework should do today if they are using input-output. So we start with the file system. We set a directory, and ensure directory means that if the directory does not exist, it creates it. It creates it for us. And it creates that file provider, the class that do the mapping between that AFS and that and the disk. We also provide here different channels. What are the different channels? You have seen here we have only channels 0. So we every time we do a store or store root, as you have seen. There is one thread which processes the entire object graph and saves that to disk. That's fine, works in most cases, except if you're performing a lot of operations on your database. You ask a lot of times to store the content, which means that that one channel, that one thread can become a bit of a bottleneck. It means that it slows down your application. Here with this example, I say that there are two channels, so that there are two threads. So that means that the work to loop over the entire object graph and to store the binary data, etc., is divided by two threads. So that means that it's not 2 times as fast, but it is faster than only one, because you have the thread overhead, you have the maintenance of working together, but then it goes faster. This needs to be a multiple, a value which is divisible by 2. So you have 1, 2, 4, 8, etc. Because internally, the classes and the entire object graph is divided based on some bit hash map, which means that if you have 3, then some of the objects will be missed because yeah, if you have 3, then the value 4, if the hash map for that object would be 4, then that would be missed. So put here values, there is a check. So if you put something else, you get an error. But I put here 1, 2, 4, 8, 16 is probably already a lot, which is not really needed, but up to 8, I think, makes sense. Of course, depending on the CPU power that you have, because it does not make sense to run 8 threads on a single core CPU. We can also have a backup. A backup means that it is stored in 2 places. It is another directory, or it is a database. Or if you store your primary here to the database, then your secondary can be another database, can be a can also be the file system. So that is to make sure that at any time you have a copy of your data. So in case you would lose that file, those files are corrupted or whatever, then you always have that backup at hand there. So it is only written to, so this entire storage manager only writes to this backup system, and reading, if you start up, is only from this primary storage. What we are maybe thinking about is creating a backup system, which is a real database system with tables and fields and rows, etc. Why not? And that's all ideas that we are playing with. So if you have ideas, please let us know what you like to have, what you find useful, what you find necessary in order to make successful use of MicroStream in your environment. Let us know those things, and we can of course discuss this and see what is possible. So this is the level 2 configuration. The probably added 3 or 4 things, as you see here, which are configured most of the time. As I mentioned, there is also a level 3 configuration where you, with a foundation and with some callbacks, where you can actually configure all, like all 15 or 17 subsystems, or provide custom implementations of all those subsystems. But that's only for the MicroStream ninjas, I guess. This example shows also that I hope it shows here in load product. So again, it starts with a root object. That's always mandatory. This time that which is one of the best practices, is that you have a final list of something, final list of per product. So this array list does not change. You can add or remove products, of course. But that also means that it is there, it is correct, because initially I also had it wrong. You see that I don't put a store root here. Why not? Because the first time, yeah, this is my empty database storage. So if it creates here the embedded storage, it sees that the file is empty. So what does it do? It takes this initialization, this initial empty database, or it can be even filled in. You can add some product here already. It stores that immediately as the content of your database, using that store root method that I used in that Hello World one. But after that, I never use that that store root anymore, and that has a good reason, because there is what's called a lazy evaluation in the product. root here. So if I say for a second time, so I store it the first time, I have a root object with a list with 3 products, for instance. I store it, it's fine, it's done, it's there. I add 1 product here to that list, and I ask for a store root again. Well, for me, it was a surprise because I did not read the documentation or was not paying attention. That 4th product is not stored if you call store root because of that lazy evaluation. It tries to do store the root and sees then, yeah, but oh, this reference to that error list is already stored and it's not changed because the reference is not changed. Okay, the content of the list is changed, but the reference is not changed. So he sees that it is a reference which is already stored. So he says, well, I don't need to do anything for this anymore. And he continues. Actually, it is the only thing that he needs to do. So he stops there. So that 4th product that I added here will not be stored by calling store root because it is a bit efficient or tries to be a bit efficient so that it only tries to try to store the changes. So how do you change then? How do you store then things properly? So I see, you see here, let's continue with the example here. If there are no per products, I say load per products. I have an error list. And I add all those, well, let's put there 4 to make it unique. And let's store those products, but not by storing the root, but storing the list. And what does it do at that time? Well, he sees this array list. So he starts now at this level, not at the root. And he sees, oh, there are some items in that list. The first 3 items, I had to continue my example of before. First 3 items, well, they are not changed because they are the same reference and they are the same address reference. But I see a 4th one, a new one. So at that point, he only stores an additional product to disk, not the 4, only the 4th one. So what is now the rule? So the rule is always use store. That's an easy thing. And the second thing that you need to know is store the thing that has changed. Sometimes it can be a bit cryptic to find out what has changed, but here the list has changed because we have added some products. So that means the list is the thing that changed. So we need to store the list. If we have a product somewhere, we do an update, and we have that find that product based on some kind of ID, whatever, and we do product set name. We change the name, for instance, from that product. A new name. What is now changed? This product. This product was already in the object graph, but of course it got a new name. So what do we need to store? The product. So by doing this, he sees that there is a new string as a reference, and he stores actually only that new string of the product. That's something what a lot of people struggle with in the beginning, to define actually what is changed and what needs to be stored. But for me, if you say use store and provide that instance that has changed, so name is changed in product, so product is changed, give that instance to that method and everything is fine. actually there is a, instead of a lazy evaluation, there is an eager evaluation. So that means that whatever was stored before or not, store everything again. But yeah, that's not very efficient in terms of size and CPU, because that serialization comes with a cost, of course. It's not that it is dramatic in performance, but every CPU cycle costs some time. So that eager is there, but I would advise not to use it and find out the proper sequence of storing. And I guess a lot of people struggle with it because it is different. We are so used of storing entities and database records that yeah, it's a slightly different way, and we need to get used to it. But I guess you can manage it. It's not that difficult. Questions about this? About this example, that was mainly about that channel count here and what part you need to store. So then if there are no questions, then I'm going to the next one. Because what are the limitations of our database in memory? The amount that our JVM heap can handle, of course. That's the only limitation. But what if we have, and I don't say that you need to have the terabytes of data, but what if we have terabytes of data? Can we still handle it? Clearly, it is not possible to load it immediately at once into memory. But there are ways within MicroStream to have a terabyte database and only inspect parts of it. It's like not reading all the tables, but reading only one table. Again, just for an analogy, because we don't have tables in MicroStream. So that's with lazy. And the decision was made to make it explicitly, because then, yeah, it's easier to know what the system is doing if you explicitly say, well, this list is a lazy list of strings, rather than relying on proxies and like JPA does, and then you get those lazy loading exceptions and those kind of things. No, don't rely on hocus pocus of some framework. Just make it explicitly so that the developer clearly indicates what his intentions are, and that you as a framework can provide what the developer asks for. What is now a lazy reference? A lazy reference is something where we have an instance of, we have here a lazy of list. So if we run it and we load that root from disk, well, in the beginning, the list itself here is not loaded. It knows that there is a instance of type lazy, and that it refers to a list, but the content of the list is not loaded. So the actual strings are not loaded. So if you would ask the number of entries in that list, the system would not know it. Java would not know it because it's not that it is an empty string, it's something that does not exist, because the moment that you ask how much items there are in that list, MicroStream will make sure that it reads that entire list from that storage and can provide you the correct answer. But before, before you access the size method of that list, it is not known. It's like a bit like that cat in the box. Is it that or not? You cannot know until you open it. Here it is, you don't know the size of the list until you explicitly ask for the size of the list. By using this, you can, of course, have the data, have links to the data in your terabyte sized storage, but you don't need to load it. And by carefully, and that's that becomes here also important, then of course, by carefully setting up your route, by designing your route, how are your data going to be accessed? When do I need lazy? When do it need it? When do I need it to be available all the time or not? Etc. By carefully designing your database, so that becomes also now part of the work that you need to do. You can create the terabytes of the data which are manageable in a few megabytes. How can you use this kind of thing? For instance, you have a list of orders, but they are, for instance, they are grouped for each customer. So if you want to have a customer, the orders of customer, you know the customer. So what you can do, for instance, and this is a bit of pseudocode, you can say, give the list of order. You lees the list of order. This way you don't load every order by every customer when you start up the system, but when you do a get with that customer, or maybe better the customer ID, which is a string and not the entire object. When you do a get on that map, you get that lazy list, so it is still lazy, it's not loaded. But when you go then to, for instance, with the Stream API, loop over each order in that list, then at that point only those orders are loaded for that customer. And if you don't need them anymore, you can say, well, clear me the lazy references, and the reference is still there, but the data is no longer there. I try to show it to you with the available heap, etc. But yeah, that fails, of course, because as you probably know, system.garbage collection is only a hint. And whatever I tried, he says, yeah, I don't need to do it now. So I cannot prove to you here that the data is no longer in memory. So that it has cleared some, free some memory, but actually there are other tests that we do to make sure that those lazy things effectively work. So back to the example, a lazy list of strings. So again, we do the easy, simple one. And if the always available is null, so that means the entire database is empty, then we load some test data in it. And actually that test data is, where is it? Here, create data. It creates 50,000 random number strings, random strings with a length of 2048. So it is already rather large, but of course not terabytes. When I run that the first time, as I said, I try to be clever and try to trigger a garbage collection, which failed. But it's still there because it is important here that you can see the available heap at start of creating those 50,000 strings is 243 megabyte. At the end, it is 147. So I created about 100 megabyte of data. So if it's now it is stored and it is loaded already, sorry, it is stored and available already. Let's see if I just I start the embedded storage manager, how many available heap do I have? I can ask for that lazy are you loaded, yes or no? And then, as I said, I'm going to look at the size. So actually trigger the system to load the data and then check the free memory again. And I hope that is more than enough proof to say that, okay, I start with 220 megabytes. I peek at the data, is lazy data loaded? It said false, so, but it did not load it. Okay, I lost a few kilobytes, but not that 100 megabytes. And then when I actually go inside looking in the box to see if the cat is alive, then you see that it loads that 100 megabytes. You also see how fast it was. You cannot see any delays between it. It's not the super fastest things that exist on Earth, but it is good performance. Questions on the lazy? Besides this storage of the data, for instance, this is the lazy data. So this is here. You see, I use 2 channels for that here. In these 2 files are that 100 megabytes. Besides this functionality, which is the main functionality of MicroStream, that it's makes that your Java objects survive a restart of the instance, and that the data is available again when you start it up. There are a few side functionalities. It's maybe a bit too harsh to say that there are side functionalities, but there are a few additional functionalities based on this serialization, because the main thing and probably the main thing that is in the entire framework is that serialization. So with that additional functionality here, where we can expose that that basic streaming, and not streaming, that basic serialization functionality, that binary function persistence, we can expose that apart from all the rest. So you don't need to store it to disk or the database. What if we just want to serialize an object graph? We can do it in Java, the Java serialization. Clearly, MicroStream can do that also as part of the database, but that piece of functionality can also be extracted and only used to do the serialization. The serializer class and the serializer foundation, that's another name for that builder, can be accessed through that additional dependency in the POM file. And since we don't have that that information about types, what we are going to do, because we are just working here with these binary data, we don't have the type dictionary. We need to, it is best that there are a few situations where you can find it out and etc. But it is best that you register all the classes that you are going to serialize. Of course, not the Java lang string and all kind of these things. They are done automatically. Basically, everything, and that's a bit of internal thing, so that can change. Everything which is smaller than this, what is it, 1 million? Everything with an ID smaller as 1 million is done automatically. Those are the things like an array of doubles here, an array of objects, etc. So all those things are done automatically, but all the rest, it is best that you register them explicitly. And Yeah, the serializer, what does that? What does that do? That well, that serializes your object graph to a binary data, and that binary array data can be serialized back to, again, an object. To show you that it can handle circle references, not all serialization platforms can handle that. I have created here an example with a serial reference, namely the boss is also an employee, but manages 3 persons, but there is also a link from the employee back to, you see, to the boss. So if you print out a hierarchy, well, I print out the references because otherwise you get an infinitive loop. But this is a classic thing of a circle references. And if I run that example, then you will see that it handles that just fine, because it does not store all the actual values, but also use references. And then you see that this employee with this, what's called the pointer, so that's kind of a hash code of the address, is a boss, and his direct reports are person X and Y, etc. So you can see all those things. When I do the deserialization, you see that the boss now has explicitly, they are not the same objects anymore. This is another instance. Of course, the content is the same, the name is the same, his direct reports are there, and the referral, the circle reference is again intact also. So the person X as manager is still as the boss, just as it was here in the original data. That's one of the, let's call it side steps of MicroStream. Another one is caching. For those that you know Jakarta, well, no, it's still at Java X, so the Java EE specification, because they have left it behind under the JCP, has the JCache, so the standard on how you can cache the return of a method, etc. MicroStream implements also this JCache, so by adding the correct dependency, you have an entire implementation of JCache, where you have the possibility to store the content of the cache as a binary data here, just as if it was a database. So that means that your cache is not in memory, and thus your cache itself can survive a restart of the runtime. Other things that we are working on is that we are working to use this in a really clustered environment. There is now one restriction for the moment, and I'll show it the easiest way by going to the hello world. We can only have at this concurrent only one storage manager that points to the same directory. If we would have 2 storage managers that point to the same directory and they write at the same time, so that means they're then storage manager 1 write and storage manager 2, etc. Then for instance, from 2 different JVMs, then we have a corruption of our data here. So to solve that, it's already possible with a bit of coding yourself to do it yourself, but we are now working on a MicroStream cluster product, which you can install on a public or private cloud. Probably it's only for AWS for the moment, I think it is, but the idea is to have it available on every kind of cloud, so that you can have all your microservices share and reuse the same storage. Are there any other questions? Because it's not the end of the MicroStream, but it's the end of the standard basic microstream functionality. If you want to learn more about microstream, just as there was this Payara Micro training, there is also some microstream trainings, and next week there is the advanced microstream training. So the basic was scheduled last week. There is one, I think, in September or October. Let's filter on microstream. There is a fundamentals again on September 27 and September 28 for the EU region and US zone. There is one on October 4th. So if you're interested to learn more about all the microstream things, then I would say register yourself here. And again, if you put the discount code microstream 2022, then it should be 100% discount. Yeah, okay, I first have to check. So then you see your entire subscription is for free. So if you want to know more, please reach out to us or subscribe to one of those things. Could you give us a real life example of when it's useful to use microstream? That's the question. Yes, I can give you a real life example. Let's close me this first. Let me go back to this thing that we, well, it's one of the cases, because I think the only limitation is your imagination, how you can use microstream. One of the things that where it is useful for is, for instance, as I mentioned this morning, you have all those services, and as I said, people tend to perform a cache, to create a cache for each for the data, because if you need to call from here, what was it, the product from where to the stock one, and all those, if you have like 10 or 20 or 50 of those calls, that's way too expensive. One of those things to put that cache there, yeah, is then microstream, of course. If you have your data available in memory, you can use it, and the cache is then also available on disk because of the microstream functionality. So for me, that is one major thing. That's then not, let's start small, maybe in the beginning. That's not that your primary, your unique primary data is stored in microstream, although that is possible. There are several customers that are doing that have just dropped their entire database and are just using microstream. But for instance, if you are looking to store this cache data, if you lose them because you made a mistake of performing the store method, etc., that's not a big deal because it's not your primary data. You can always recover that. So that is for me one very useful case, which is, as I said, a small step, a slow introduction of it. But yeah, there are people that just drop their entire database and have converted it to that microstream storage. Other questions? There is already a few integrations available. I showed you at Java SE, but yeah, it's not. Yeah, you can use that same Java SE within Payara Micro. That's not a problem. You just add the microstream dependency to your per project. You can instantiate the storage manager. In the post construct, for instance, of a bean, actually, I did that in one of the two exercises of this afternoon. But there are also integrations available at other levels. First of all, there are already 3 products that have specific integration. So not about this CDI integration. So there are 3 products that have created their own custom integration of MicroStream. And one of them is Helidon. They were the first one September, October last year or something. So they have created an integration so that it becomes easier to use it within the Helidon product. And it offers some additional functionality. The second one is for Spring Boot. So for those who are working with Spring Boot also, there is a integration. It needs to be updated because it is maybe a bit too limited for the moment, but there is also already an integration with Spring Boot so that you can define, for instance, your storage manager as a Spring Bean and those kind of things. Lastly, last week, there was the Micronaut team that revealed that they have also integrated the entire MicroStream product within version 3.5 of Micronaut. So again, there you have some advanced integration with annotations, even with multiple storage manager that you can configure through properties, through those config properties. And last of them, there is a generic CDI integration. So Elias, I come back to your question about benchmarks. There is a generic integration for any system, any Jakarta. Well, it's not, well, it is Jakarta EE because that's CDI, but it also uses MicroProfile config for the configuration. So that's a generic integration. So it works for all vendors, including Payara Micro. So I can show it here today. This one was a first tryout, that generic one. In the meantime, we have learned that there can be some improvements. So I would suggest that you look out for the next version as 7.1 or maybe 8 of version 8 of MicroStream to have a more advanced integration instead of this one that I can show you today. What does that integration do for you? First of all, I have, is it inventory? Yes, it is inventory. The root class, well, the idea is of that integration is that you do not have any kind of statement related to MicroStream in your entire application unless a few annotations. That's the idea of the integration. As I said, there are a few shortcomings that I can mention the version that we have now, but it is already working as this example shows. And for example, we have other examples also. So the idea is of that the root can be, or the root must be indicated by this storage annotation. This storage annotation is a MicroStream specific one. It is also automatically converted then in a CDI bean, so you can inject it everywhere. So that means that your root of your object graph is available at any kind of CDI bean. So you can then start querying on products like this one, or find, and here there was a find with stream again. You can do a delete, you can do an update. No, there was no update for the moment, but you can do update, of course, etc. So that's the idea. The root is turned into a CDI bean. Secondly, if you have and it is a repository here in the naming. You have a CDI bean that adds a certain product. You remember adding a product, that means that you need to save it again. Then you don't explicitly call storage manager store here, but you just annotate it with store. It's a kind of similarity with a transactional, but yeah, it's of course not a transaction and not one. But this CDI interceptor, you know what it does now, a CDI interceptor. This store is a CDI interceptor. You see interceptor binding. Then he stores the lists, explicitly the lists and the collections within your root object, so that you do not lose your changed data. And basically that's it. Just need to indicate this is my root, and this is when I need to change my root, and I don't need to change it when I do just a find, but I need to change it when I add or delete something. And last thing is, of course, here for convenience, just in the config properties within the path itself, you can have the configuration of your directory and the number of channels. These values they are coming from, if you do not, because I did not mention it in the basic, but you can also configure your entire storage manager through property files. That's like this one, or even XML files also. And these names here at channel.count is one of those properties, and is here prepended, and so that we don't have a clash with some other frameworks. I'm not going to run it. You have access to the code. Just a clean package, deploy that WAR file. Everything is documented. When you run it the first time, you can add some products. You stop Payara Micro, you start it up again, and you will see that you still have that same product and that same list of products available again, because yeah, it stores it in this directory. The point is that why it is missing, it was a first version, and it is a good version. It works perfectly with a few limitations, in the sense that if you, for instance, update a product, then this store will not change that updated product, because remember the rule: if I change the name of the product, I should store the product itself, not the list of products. So that's the reason why it's not 100% perfectly for the moment, but as I said, watch out for future versions to have a better generic one. But otherwise, with Helidon, for instance, and Micronauts, the integration is already more advanced than this generic one. Any questions about these integrations? Then there was a question about benchmarks. Yes, we have done benchmarks, and it will be no surprise that reading from memory, even with very complex queries, is much faster than if you read from the database. The serialization framework, what I showed, that's a bit of a mixed result, as some of the serializations, like for instance JSON, the serialization from Java to JSON and back, they are a bit faster than we are, but others we are faster. We are, for example, faster than the JAX-B serialization. And you mentioned specific cache. I did not do that myself, but what I heard from the team is that there is that caching solution that we have here is much faster than EH cache. So if you want to have it purely based on performance, then I would say yes, you can switch that cache solution with the microstream cache provided one. If there are no other questions for the moment, then I'll suggest again that we have a break for around 10 minutes, and then we do the last topic, and that's integration testing. Okay, see you in 10 minutes. So we have now we have come to the last item, security. If you don't count that, as I mentioned, it always is forgotten in the beginning and it's an afterthought, which it should not be, but okay. Except security, the last thing that we need to discuss is probably integration testing. As we have seen, CI/CD automation is a very important part of cloud native way of working. So integration testing and integration testing in particular is then, of course, a very important topic. And I did not create a slide about it, but there are several levels of testing. You probably know that. I don't need to explain it. You have this classic unit testing, where you just test a method in isolation. And that's fine. That can give you some ideas, especially if you're testing around the corner cases. Then you can find a lot of issues there upfront just by doing integration testing. So don't skip integration. Don't skip unit testing. That's an important part. But after that, and especially then also with microservices, you have to test the things in combination. With a method, testing a unit, you just provide some a parameter, and yeah, your method works with that parameter. But is that parameter a real world value, or is that something that you just use there either to make the line count, the percentage of lines that are tested happy, so that you have more than 80%, or is that a real life value that can happen in production? And because that, of course, is important. And you know that most of the time only when you're doing those integration testing, real testing, like I did, I started up the program and I called an endpoint of that, and I saw the result of it. That's integration testing. That is what is important. And a lot of people are using mocks for that. So if I call that, then I simulate a response from another system by returning X, Y, or Z. But again, that is according to what the developer thinks, what the external system will return. It might be that it returns something completely different, where you as developer did not thought about, and that your application will fail. So the ideas of mocks, again, can be very useful. It can be very good, but make sure that you are not testing your mock values, and make sure that you are testing some real world stuff and not something imaginary. Sometimes I have the feeling that people that they just want to have something which passes, and that they manipulate their values in such a way that it passes, but that the test itself has no real world value, that it just, yeah, it passes, but you better could have not tested it, because that would save you the time of writing the test. So we need something real, but that's difficult. If you need the database up and running locally or remote, it needs to have a certain specific data and initial data which your test assumes that is there. I don't have a user, I create a user with is it valid, appears it in the database afterwards, etc. So all those things, setting up those things is quite challenging, and it's made a bit more easy. It can be done a bit more easy by using that test containers framework. The idea about that test containers framework is that your application has several dependencies, and those dependencies are provided. So a real database for you is provided during the test, because it is started up as a Docker container, just as your application yourself. So through that entire Docker system, it became much easier. You saw it also. I just did a Docker run of MySQL, and I had a MySQL database there. I do a Docker stop MySQL, and it is gone. I don't need to install it. I don't need to maintain it. It is installed from scratch. So that's that makes it a lot easier to have a repeatable environment, an environment where you can repeatedly have the same situation over and over again, and that your test can made consistent. So I was not really planning initially to talk about a lot about Docker, but there was a question yesterday of Jerome. Can you have a few short words about how to build mainly integrate then your Docker build within your project, your creation? So I go quickly over it, and I'll show you maybe one nice trick that not everyone knows. So this is about creating a Docker file, a Docker image, sorry, and that Docker image can be used to run a Docker container. First of all, always make sure that you understand the technology, and I will say in a moment why it is important. So don't start integrating a lot of Docker stuff in your Maven build file if you don't understand how a Docker image is built, because if you do that, then you probably lose sight of it, what the purpose is, how things work, and will make it way much more complex than it should be. So I have here a simple application. Is it one of the test applications that we used before? No, it's just the Hello World. The Hello World that I created, well, that I extracted from the first Jax one. And actually, you can run that application within Docker in two ways. First of all, you can create a new image based on top of Payara Micro in this case. So the naming convention is that you have Payara/micro, that you here have the version number, and that you have here also the JDK version of that image, because you have JDK 8 and 11. So without any extension here, you have the JDK 8. With JDK 11, yeah, you have JDK 11. And you can create a custom image by extending the default one and copy your demo WAR file in that directory, which is used by default to look for WAR files when it starts. And deploys your application. And you can run that. You can do a Docker build, so you can within the root of that project. Then I have a Maven clean package, but to be 100% sure, I do Maven clean package. So I have my WAR file there, and the next step that I do is then creating that that image, which normally goes very fast because the only thing that you actually need to do, as I mentioned before, the first one is cached, so that's already known, except for the first time when you need to download it. And the second step that you need to do is copy that file here. And if you are wondering, this one that says the owner of that WAR file in that image is also the user that's running the Payara process within that image. And I have a new image. That image has several layers. I added a layer on top of it. And when I run it, I can run it like this, where I just say, Docker, run me this image that I created. Always a good practice to explicitly use version numbers. You should always use version numbers. And then here, now I scrolled a bit too far here. I'm exposing the default port 8080 within the container to port 8080 of my machine. It starts up. You can do it also as a daemon so that you don't see the log. Takes much more time because I on purpose limited the amount of CPU and memory that my Docker system has here on my local machine. Otherwise, it can take over my entire machine and I can't do anything anymore. And then I can do just a curl. Let's do that. So I can do curl. I'm not going to do it with all of them, but the first one, localhost 8080. What's my, it's demo data. Hello, and I have my hello world. Good. Make sure that you understand what you're doing, that you say, oh, I have here a copy of that in the image. Actually, you don't need a custom image. That's sometimes it is useful, but most of the time, if it's just copying the WAR file in the image, then you don't need to have a new image. Because you can do what's called volume mapping. I can map this target directory where my WAR file is. I can map that to that opt Payara deployments directory inside the container. And then I can say, well, run me the official Payara image as container, put the entire target directory as a volume. And so that's basically swapping out the directory, what it normally sees with this target directory, and then deploy me that demo WAR file that he finds there because it is actually here, but it is linked. Why? Well, why just create a new image for just a simple thing that you can do without creating a new image? Remember that you should try to avoid all additional resources that you create you need to do a build that was fast, okay, but you need to, if it's not locally, you need to push it to a central registry. Your Docker client needs to push it, pull it again from that registry, etc. If you are able to run every image, every application that you have, if you have multiple ones, then with the official image, then this is a much more efficient way. Okay, I assume there is a question. Clever. Okay, thank you. It depends, of course, how the image of the is provided. If so, I know that Payara took great care of creating their images properly. So it was not the first version, but over time they made it possible to use it in all those clever ways, as you call it. But yeah, it's just to have an optimized way of accessing your resources. Next step is that you say, well, but most of the time you run your application when you're developing not in a container, but okay, let's say that you want to have the Docker image created. You're going for a custom image, and that you have your Docker image created every time that you do a Maven clean package, for instance. Then there are mainly two options with Maven. As I said, I'm not familiar enough with Gradle yesterday to know all those things. Probably there are similar things with Gradle. One of those things is what's called the Docker Maven plugin from Fabric 8. Fabric 8 is actually a more or less a Red Hat product, but they provide Docker Maven plugin. Sometimes you will see the Maven, the Red Hat background in all those things, especially in the next one, but okay. They have a Docker Maven plugin, and with that Maven plugin, you can define your image through XML. Yeah, well, first of all, I'm not a fan of to learn something new again. Okay, this is now easy because I'm just need to copy the demo.war file in that official image here, and I give it the name, training 2, and the version number. But I need to learn what it is, and something like I have I'm need in an assembly, and that copies the artifact. Well, the artifact is actually the demo.war, and I copy it from that directory to the target directory. That's not always clear if you look at an example at the documentation. So yes, you can do it. I will run this. You will see that it creates an image perfectly. But I'm not a fan of learning what's called a new DSL, domain-specific language. I'm not a fan of creating something because, yeah, I probably know already how to create a Docker image based on that Docker file from and copy, etc. By the way, this does not copy it with the correct owner. It works, but sometimes you can have an issue. But there is another option. Then instead of doing this, you can say, well, okay, initiate the information that I do, but actually I'm using a Docker file because I know how to write Docker files, and well, I know a few things. So I'm using this Docker file. This comes from, yeah, well, that took me a while, some months ago, to find out. That's because this assembly officially has the name Maven. So you see, sometimes they can make it so difficult. But if you run this, so if you run, you can do a Maven. If you put the correct execution here, I did not do it, but if you put the correct execution here, that this plugin is executed at the time that you do Maven clean package, you have your file ready, your image ready together with the Maven clean package. I quickly assembled it yesterday evening, so it's also available in that extra directory. So I can do Maven Docker build, not the Docker, Docker, please. Then actually I create two images, one with this domain-specific language and one based on this actual Docker file. Come on, oh, there is. I always put those things at verbose true so that you can see, oh, step 1 is from this image, step 2 is copy, he does, is it the one then? And then he copies it, is the Maven var, so it is with the bis one, so with the Docker build file, then you see he copies it, and yeah, that seems okay. And the other one is here. You see, it just says copy target deployments. Is that working? I don't know. And then I have found a wonderful tool for that. You can do it for a lot of things. It's called Dive. I'll show you the thing, show the Docker image Dive. This is the repository. You can install it in many ways. It's Windows, it is everything. And I'll show you what it does if I can reach the chat properly, because I have so many windows from Zoom here overlapping. So I would say dive, and I just need to specify the name of the image. And then he does an analysis of the layers. So it is a good thing to see if you have your layers a bit correctly. And you can also see what it has done. For instance, from the bottom, the from, yeah, you don't see the from, well, this is not, this is the Payara one from, so this is some generic base image with the OS. It's with the hash code, so it's not with the names. Okay, it's someone created this in his free time, so you know you can't have all the things. And then you see the last layer, at the top layer is that 5 kilobyte with a copy with, you don't see the name, but the good thing is you can look at the file system at that moment. So look at opt Payara deployments. Oh yeah, there is my demo var. It worked. And then you also see that this copy just copied that single var file. And that's where is backend, and here that 81 megabyte is Payara Micro, is a good layer. And the entry point, so the shell script to launch Payara Micro is in a layer below itself, because this shell script does not change every month, but this Payara Micro does change every month. So they have done their homework correctly, and they have created the correct layering system. And for me, I'm using it to see, oh yes, that plugin did what I was expecting. It copied the correct var file, and only that var file, and not other rubbish, etc. in the layer. Dive, something which I find useful. It gives also an estimation. Where is it here? Efficiency, 99%. It's very high. Because as I mentioned, every layer is read-only. So if you in a newer layer which is higher, which is more on the top, delete a record, or sorry, delete a file, the file is not gone. It's still in that lower layer, but not in the final container. So you can have an image, if you don't care, if you don't watch out, you can have an image which is massively large and results in a small container. But of course, the loading takes a long time, so that's not a good one. Efficiency of 99% is, of course, very good. So was using this for some time, this Fabric 8.1. There is also, strangely enough, a Maven plugin created by Spotify, so you can have a look at that also. And the work that was done here by Red Hat here for this Docker Maven plugin, they evolved it to what's called Eclipse JCube. So it is an official standard. Well, it's not a standard, but they have released it as JCube, and it's now called a Kubernetes plugin, because you want probably not only the Docker image, but also want your Kubernetes resources, your deployment YAML, and we all know how we love YAML to write in those things. Problem is that, as I said, it is so Red Hat oriented and also a bit Spring Boot. So feel free, Spring Boot lovers, to check it out. That that it does not really work with Payara Micro. For example, it works to create that image. That's in the same ways. It creates an image with that DSL and here based on the Docker file. But if I try to create resources like this, then I found 3 issues. These resources cannot be combined with images. So you cannot create your Docker container and your Docker resources in one and the single Kubernetes thing, plugin. You cannot specify the image name for the Kubernetes deployment, so this will just fail. It takes some random value. And the output, and that's bothers me the most, is written in the target class metainf classes. So this means that the entire YAML becomes part of your application WAR file. No, thank you. So this, yes, this Docker Maven plugin, if you want to integrate it in your Maven build file, that's nice. Coming to the real question, integration testing based on test containers and Docker images. So I have here an application. Now this one is an application which is using even a MicroStream. I have a endpoint with products, and I can find a product and I can insert it, etc., etc. So this is okay. It's a very small application, but this is an application. If I need a database, well, then I can say how you I don't know all the syntax by heart, but I can say how you can create that integration test. How do you create a test with test containers? Actually, it is a unit test, but okay, you can make it an integration test so that it runs at the appropriate Maven lifecycle by put the name as IT. And this test containers annotation, that's an extension. You see an extension from JUnit 5, so that you can start your application in a Docker container for your test. And that's also the reason why I showed you how you can run a Docker image without creating a custom image for Payara, because I'm creating here, I'm defining here a container, which is generic, because generic is something that you define. The default ones, there are default ones like the MySQL container. You have a Redis container, which do some configuration for you already. But I'm using a generic one. I'm using the basic one that I'm going to configure myself. It starts from that same Payara Micro 5, JDK 11 one. I need to expose port 8080. That's the -p that you saw if you run it on the command line. And I copy a file to the container. This is one way. This is actually, well, it is a generic container. It is, and it extends this one with actually copying the WAR file at this location in that container. So basically, it's creating a new image on the fly. So it's not really the same, but yeah, then you need to know some internals. This WAR file, that's a specific file. That's not just a standard file, but that's what's called a mountable file. And you see that's from test containers itself, that you say a mountable file for that host path. And of course, that refers to here, but the name that it is defined, where is it in target here, which is generated, of course, within the image. I can give it a name what I like. This is also by default the context root. One thing that you need to say to test container is how it knows when the process within the container is ready to accept requests. You remember MicroProfile health? We had discussed this morning. Well, this health endpoint will say up and status 200 when the application is deployed. So I'm saying to test containers, wait for an HTTP health status to 200 is implied. And I update the command that is to launch the container. So that's something that I additionally apply. I can do that also on the command line. So I deploy that app deploy, that app var that I have here. I say that Payara Micro does not need clustering. And you saw it this morning, the Hazelcast that finds out if there are more things running. Suppose that I'm running this integration test in parallel, which is possible then, of course, then, well, I don't want that these instances talk to each other because there is no need to it. So I say no clustering capabilities, and the context root is /. So this is my application that starts, and when it's ready, my then my test method starts, and then I can start calling endpoints. But MicroProfile REST client gave you an easy way of defining how you can how you call those endpoints. Remember? So I created an interface which says produce and consumes application JSON, because that internally there is JSON. That's the path, and I have methods get all, find by the insert for the post and delete. These are basically equivalent to what I have here in the controller. See, I have here path ID with a get and post with an insert, and I say also here consumes and produces from application JSON. Actually, this interface can be used as the parent for this controller. So you can say product controller extends this product service if I put it, of course, in the main branch and not in the classes, in the test classes. And then I do not even to repeat myself, which is better, but I wanted to keep it simple. So once I have this definition of how my endpoints look like, I can do a setup and saying that, okay, I create a URI. Where is my application located? Well, that's localhost. Port is 8080. Well, yeah, within the container, but test containers maps it to a random port between, what is it? Between 16,000 and 64,000. So because of the fact that you would be able to run it in parallel. If you run it multiple times and you map it each time to 8080, well, then you could not run it in parallel. So I'm asking the container, what's the port that you assigned for 8080? And that's I'm using for the URL that I'm providing to my REST client, to my builder, to create a real implementation out of that interface. I need to provide it with that URI that I assembled, and I explicitly need to say that it needs to support JSON-B, so I need to register the JSON provider. That's because we are not using annotations where that is all done automatically here, and we do it programmatically. But the nice thing is now that we have here a class, well, a proxy is something that is created automatically that is capable of calling our endpoint within the container. Another thing that I like to do is to see the log file of Payara in the container, but in my test output. So you can say, you can follow the output of the container with this consumer, and that is an SLF4J log consumer. That means that you have to provide some configuration for it, and I have chosen to use logback for that. So I'm outputting the information. Was it too fast, or are all the bits and pieces still a bit clear? Because we have our integration test. We can now first call service get all, so that give a list of all products, which is initially is empty. Then we can say insert me a product. That means I call an endpoint again and I add the banana fruit with rating 5. And then I can call the service again, that get all, and I expect size 1. And I'll expect that the ID, the name, and the description are the one that I supplied in the insert. Run test. You can run it from within your IDE. You can run it Maven clean integration test. Of course, that's all possible. And you see, this is the log from test containers itself on the client. So it checks a few things. It checks. It uses the standard Docker client, so it is now indeed my local host, but that can be remote. It can be any kind of server. The first time, it sometimes gives me an error that it cannot find something. It continues, but that's the reason why it is so slow. So you see failure when attempting to look up, blah, 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 but it continues afterwards. You see, it starts up Payara Micro, creating container for image. So, and it is now using the wait strategy. So it's now waiting until Payara Micro is started within the container. And then it starts executing these tests here when everything is ready. It's also super slow because I'm sharing it. And this is a standard error, but this is the log from within the container. So you can see, and that's especially useful if things go wrong, which will go wrong the first time. If you do those things, then you can see what it is outputting and see if there is an error here in this log, and then you can learn what you have done wrong and you can correct it. You see it has run with some bizarre host because that's the internal host of my container, but these URLs were available. And then the test was green because yeah, it did what was expected. If you are using a database, then for instance, then you can say that you have a container and public static and then you have a MySQL container. Probably I need to add some dependency, but I guess you get the idea. So you can say, I need a MySQL, I need a Postgres, I need whatever. And then it starts it up as part of your test. And then you can even ask that container, give me your URL for the database, give me your connection credentials, etc. So all that information you can retrieve from test containers because they started up with some, at some host, with some URL, with some user, and with some default password, which is maybe not default. So that's the reason why you can ask then that specific MySQL container for all that information. Have a look at, for instance, at test containers. Test containers start MySQL, for example. You see, I need an additional dependency. You can use Gradle Maven, so they are nice. In this one, don't they have a example? There is somewhere another example how you can use it. But you see, there is a lot of databases there already. You can even start up Cassandra, Influx. You have a MongoDB and Neo4j one. And you have also a ton of other containers, Kafka one. You have, as I mentioned, what was I thinking? Like here a Pulsar, so that's a NoSQL, etc. So even a WebDriver for those that who know that for testing front end, as testing HTML, etc. All those things are provided here as modules. A RabbitMQ, it's also a nice one. Question about these basic usage of a test container. This is nice. Sorry. But yeah, okay, it's every time 4 lines. Over and over. So why don't we use some, that we create our custom container, that we create our Payara Micro container. And maybe we can add some little features which are useful, for instance, debugging within the container. Because yeah, we are, most of the time we can find out based on the logging, or we should be able to, based on the logging, see what's going wrong and then either correct the application or correct the test, because it's also possible that we made an error in the test, but sometimes we have no clue what's going on, and then debugging is of course the way to go. So I created here a Payara Micro container. So it extends the generic one, and it takes either that mountable file, that WAR file, or additionally we can provide the value for the debug. Do we want to have debug, yes or no? I'm still using Payara Micro. I'm still saying expose port 880. I copy that file to up file, waiting for health, and I'm doing that command. Still the same. But if we want to debug the entire thing, then I add a fixed exposed port. So because yeah, it's a bit difficult to say, yeah, port 5005, which I define here as environment variable, one of the JVM arguments. If my application starts, this is the nice thing that you need to do for remote debugging of a Java process. Yeah, if the container always assigns a random number at the port, I need to find it out before I can type it in here in my debugger, or connect my debugger from the IDE to that port. So that's not useful. So I'm probably also only debugging one process at a time. I'm not having those kind of multiple capabilities of doing multiple debugging sessions at the same time. So having a fixed port here is fine. So I say container port there is 5005 here on my host port. So that's a little additional thing. So I can then rewrite a bit. It is exactly the same thing, but now I'm going to use the debug thing. I'm going to use that Payara Micro container, and I'm providing that WAR file, and I'm say debug is true. And for the rest, that is exactly the same as the previous one. But it has the nice thing that if everything is set up correctly, I have already an unnamed ready here. Let me start with the product controller. Do I have debug line somewhere? Okay, I have here already a debug line. So I can start it up. I can just run this because I don't need to debug the test. I need to debug the application. So I run my test. And because I hope I did it, because I said here, you see, suspend is yes. So my process even waits until I connect my debugger. So it is starting, and then I can just on my own, I don't need to rush. I can connect my debugger, and I'm connected. You see, connected to the target VM address localhost 5000, which is actually in my container. I have now to wait until my entire Payara Micro process starts up, but yeah, okay, I have a bit of time. I can take a sip of my coffee. And at some point, my breakpoint of the debugger will hit, and then it will show me, there it is. You see, I'm at that line. I see my item, which is coming in. I see my inventory. I can do whatever you can do with a debug. I can even say, well, if I fix, you know, that probably the IntelliJ users, if I say, well, I have found a problem as there was some calculation missing. Yeah, but now this will fail, of course, and I fix it by change the value. This one is the corrected, and now your entire process continues with that changed value, which means that the test will fail. See, expected a fruit, actual fruit corrected. Of course, if you do it the other way around, if you found out in the debug session what was wrong, then you can correct it there on the fly and see if your test passes with that change, for example. So I would strongly suggest that you create something like this, your own container with the default value, so that you don't need to copy it over and over again, and that you can add something little nifty as a debug capability. By the way, with that debug, I extended the startup time from the default, what is it, 30 seconds to 60 seconds, so that I have time to connect my debugger to that process that started. Any questions about integration testing and test containers? Anything specific about these 2 days? Because actually I'm at the end of what I had prepared. So if you like to discuss one of the things more in detail, what we have done, feel free to do so. There is also that last exercise. Again, you have already the solution in that solution branch. If you want to play around a bit with MicroStream, and then you have in that repository here, the Payara Micro course repository, you have there the final advanced, the final to core, the basic final one is using the Java SE one, but combined within Payara Micro, where we in a post construct of a bean start up the entity manager, the storage manager. The advanced is using the MicroStream CDI integration, if you want to play around with that. If you want to make any comments now or in writing, I mean in mail, about how good it was, this training, or how awful it was, this training, please do so. Let us know that we can improve if needed. If you want to reach out to discuss one of these things, also feel free to do so. I'm happy to discuss these things more in detail, or provide some other trainings about other topics like security, for example. If you want to talk about MicroStream, then of course you can contact me, or you can contact Sebastian, or just the info. I think the email address is info@microstream.one. And if there are no other questions, I'll stay around for those people who wants to chat or talk privately about something because they do not want to do it in the open, which is fine. Then I'll stay around so that you can ask those questions. But otherwise, thank you for your attention. Thank you for your interest. I hope that you learned 1, 2, 3, 5, whatever things, and that it was useful investment of your time on this Payara Micro native, a cloud native microservices course. Thank you, and enjoy the rest of the day, evening, the rest of the week, the rest of the year.